plus 1 equal to x square. It's a wonderful algebraic question. We want to find 2x power 4. And so we want to find 2x power 4. So we can either find x square minus x minus 1 equal to 0. That means x square minus x plus 1 by 4 equals 1 plus 1 by 4. We take this minus 1 this side and adding 1 by 4 on both sides. X minus half the whole square is 5 by 4. With this we can find x. Right? So our x minus half is plus or minus root 5 by 2. X is half plus or minus root 5 by 2. X is positive, so it is only half plus root 5 by 2. And then we have to find 2x power 4. So even after you have found x, finding x square, x power 4, that's going to become trickier. So we're going to think about finding x power 4 algebraically. And we have an x square here, so square this. X power 4 equals x square plus 2x plus 1. Now x square is x plus 1. So x plus 1 plus 2x plus 1 is x power 4. Or 3x plus 2 is x power 4. Or 6x plus 4 equals 2x power 4. We want to find this, we only need to find this. X is 1 plus root 5 whole by 2. We want to find 6x plus 4, where x is 1 plus root 5 by 2. 6 into 1 plus root 5 by 2 plus 4. So this is 3 times. So 3 plus 3 root 5 plus 4. Or 7 plus 3 root 5 or 3 root 5 plus 7. There goes this answer. Key thing here to somehow find x and then write x power 4 in terms of x. If you manage that, this becomes a far simpler question. The value of log root 5 to the base 0.008 plus log 81 to the base root 3 minus 7. What is this equal to? And this can be written in terms of 5. This can be written in terms of 5. These two can be written in terms of 3. Root 5 is 5 power 1 by 2. 0.008 is 2 cube by 10 cube, or this is 5 power minus 3. 1 by 5, 1 by 5 square, 1 by 5 cube, 1 by 125 is this number. I'm going to write this as log root 5 by log 0.008. Write this as log 81 by log root 3. Choose this base to be 5, this base to be 3 minus 7. Log root 5 is 1 by 2 by minus 3. 5 power minus 3 is 0.008. So log 0.008 base 5 is minus 3. Plus log 81 to the base 3 is 4 by 1 by 2 minus 7. This is 8. 8 minus 7 is 1. This is minus 1 by 6. This whole thing becomes minus 1 by 6 plus 1, which is 5 by 6. This is minus 1 by 6. This is 8 minus 7. So minus 1 by 6 plus 1 is 5 by 6. This is a choice we're looking for. 9 power 2x minus 1 minus 81 power x minus 1 equals 1944. Wonderful. I'm going to write this in terms of 9 power x minus 1. So 9 power 2x minus 1 minus 9 square to the power x minus 1 equals 1944. 9 power 2x minus 1 minus 9 power 2x minus 2 equals 1944. This is 9 power 2x minus 2 into 9 minus 9 power 2x minus 2 is 1944. 9 power 2x minus 2 into 8 is 1944. Let's do 1944 divided by 8. We should be through. 2, 16, 34, 4, 32, 3. And so, or 9 power 2x minus 2 equals 243. 243 is 3 power 5. This is 9 power 5 by 2 is 243. Or 2x minus 2 equals 5 by 2. 2x equals 9 by 2. X is 9 by 4. Wonderful question. Manipulate with exponents. Get comfortable with the idea of dealing with exponents. These questions, either we treat this, sometimes we go to a quadratic mode. We'll say 9 power 2x minus 1, let it be y, and then simplify. Or we get something in common. Between these two expressions, 9 power 2x minus 2 is common. Once you get that, this becomes a very simple question. After that, it's just doing a little bit of algebra and keeping it together. Nothing more than that. The number of solutions x comma y comma z to the equation x minus y minus z equal to 25. X, y, z are positive integers. X is less than or equal to 40. Y is less than or equal to 12. Z is less than or equal to 12. Right. Or the maximum values y and z can take are 12. Maximum x can take is 40. Right. So let's think about this. From 40, we subtract this. We subtract something to get 25. From 40, I'm just going to put some numbers here. 40 minus 12 minus 3 equal to 25. 40 minus 15 is 25. X can be 40. Y can be 12. And Z can be 3. Next is 40. This works. And when x is 39, I'm going to go step by step. X equals 40. That means y plus z equals 15. And x is 39, y plus z equals 14. X is 38, y plus z equals 13. And so on. Right? So x is less than or equal to 40, y less than or equal to 12, z less than or equal to 12. How do we simplify this? We can take individual values for x and then find the number of possibilities for y and z. If y plus z equal to 15, y is less than or equal to 12. So y could be 12, z could be 3. And then we have 11, 4. So y can take values 12, 11, 10, 9, all the way till 3. And z can take the corresponding other values. From 12 to 3, this is a set of 10 values. When x is 40, y plus z equal to 15, there are 10 possibilities. Right? Y can go up to 12 and z can go up to 12. So y can take all values from 3 to 12. Here again, y can go to a maximum of 12, and from y can range from 12 all the way till 2. 12 to 2, there are 11 values. Y plus z equal to 13, y can go from 12 to 1, there are 12 values. When x is 37, y plus z is 12, y can go, x, y, z are positive integers, 11 to 1, 11 values. X is 36, y plus z is 11, y can go from 10 to 1, 10 values. Fine. So x is 35, y plus z is 10, y can take from 9 downwards, 9 values. And I'm going to go to the next slide. What we have here, values, the number of values that can be taken. We've done till x equal to 35. I'm going to go from x equal to 34, 33. But the values we have here, 10, 11, 12, 11, 10, 9. 10, 11, 12, 11, 10, 9. X equals 34. Y plus z should be equal to 9. Y can start from 8. We have 8 values. Here we'll have 7 values. 32, 6 values. 31, 5 values. 34 values. 29, 3 values. 28, 2 sets. 27, 1 set. When it's 27, you have only one possibility. So we have 1 plus 2 plus 3 plus 4 all the way till 10, 12 plus 10 plus 11, or 12 into 13 by 2 plus 21. 12 into 13 by 2, 6 into 13, 78 plus 21, which is 99. This is what they're looking for. going step by step, plugging in x equal to 40, 39, 38, all the way till 27. X cannot be less than 27 because y and z are positive integers. They have to be at least 1. How many integers n will the inequality n minus 5 into n minus 10, which is n square minus 15n plus 50 minus 3n plus 6 less than or equal to 0 be satisfied? I'm going to see if we can factorize this. First, n square minus 18n plus 56 less than or equal to 0. 14 into 4, n minus 4 into n minus 14 less than or equal to 0. So n should lie between the roots. It is less than or equal to 0. So n can take values from 4 to 14, 4, 5, 6, 7, 8, all the way till 14. This is 11 values. Very simple question. Take this, simplify this, factorize it. There's a quadratic equation with 2 positive roots and it should be less than or equal to 0. N should lie between the 2 positive roots, between 4 and 14. How many integers are there with between 4 and 14, including 4 and 14, because there's a less than or equal to 0 sitting here. f1 of x is x square plus 11x plus n. f2 of x is x. Then the largest positive integer n for which the equation f1 of x equal to f2 of x has 2 distinct real roots. These two should be equal. Then we have x square plus 10x plus n equal to 0. This should have equal to distinct real roots, or the discriminant should be greater than 0. Discriminant is b square minus 4ac, which is 10 square minus 4n greater than 0. 100 minus 4n greater than 0, or 25 minus n greater than 0, or the maximum positive integer n can take 24. If n were 25, this will have equal real roots. Anything more than 25, this will have no real roots. If you want 2 distinct real roots, n has to be less than 25. Largest positive integer less than 25, that is 24. Equate these two, get to the quadratic, and then put discriminant greater than 0. Done. A, B, C, D are integers such as a plus b plus c plus d equal to 30. The minimum possible value of a minus b whole square plus a minus c whole square plus a minus d whole square is, remember, all three are positive. And so we need to minimize the difference between a and b, a and c, a and d. And so we can try to have all 4 numbers as equal. Put this as 0, put this as 0, put this as 0. But that's not possible because 30 is not a multiple of 4. Remember, whenever there's a difference, the difference is going to be an integer, but they're all integers. And you square an integer, the larger the difference is, the larger the square is going to be. So we should find a to be as close to b, c, d as possible. And all 4 numbers to be very close to each other. 30 by 4, 7.5. So a, we should peg it at 7 or 8. All 4 at 7 or 8. If you have 2 7s and 2 8s, this will work. 7, 7, 8, 8. A minus b whole square be 0. A minus c whole square is 1. A minus d whole square is 1. 0 plus 1 plus 1 is 2. Wonderful. So this looks like this will be the minimum. Let's convince ourselves. Fine. So if the difference is more than 1 anywhere, that just that difference square is going to be 4. So we cannot have 0 plus 0 plus 4 or 0 plus 0. We have one difference being 2. We cannot go lower than this. So all the maximum should be 1. So better than 0, 0, 1, we should look for 0, 0, 1, 0, 1, 1. We should look if there is a possibility 0, 0, 1. A equal to B equal to C, and D being slightly further away. And so 8, 8, 8, 6 doesn't work. 7, 7, 7, 9 doesn't work. 7, 7, 8, 8 is the best possibility, or the least is 2. Done. The shortest distance of the point half comma 1 from the curve y equal to mod of x minus 1 plus mod of x plus 1 is, think about the point half comma 1, and from the point half comma 1 to this point. Let's put half into this. If we put x equal to half, modulus of half minus 1 plus modulus of half plus 1. This is 1 by 2 plus 3 by 2. Y should be 2. Half comma 2 is a point on this line. It seems to be a very interesting curve. Y will be entirely positive. That much we know. I'm going to imagine and draw this curve, even if it takes a while. This is going to be, y is entirely positive. It's going to be a set of straight lines. I'm going to put a bunch of values. Let's say we put x equal to 0. Then y will be 2. 0 comma 2. When x equal to 1, when we put x equal to 1, we'll have 1 minus 1 0, 1 plus 1 2, 1 comma 2 is a point. X equal to minus 1, that will be a point here. And so x equal to 1 by 2, half minus 1 is modulus is 1 by 2, 3 by 2, y equal to 2, minus 1 by 2, that will also be a point. So think about this, a wonderful graph. And so I'm going to break this into 3 segments. And when x is greater than 1, this will be x minus 1 plus x plus 1. We're talking about 2x. When x is less than minus 1, this will be 1 minus x minus 1 minus x. It will be minus 2x. And so this will be a line like this here and a line like this here. Between minus 1 and 1, it will be 1 minus x plus x plus 1. It will be 2. So there's a point like this. It is 2 from minus 1 to 1, and then a curve with step 2x here and a slope of plus 2 here, slope of minus 2 here. Curves going up. You're looking at a point half comma 1. So half comma 1. The shortest distance will be this perpendicular distance, which will be 1 unit. Draw the graph. The key points here, if you're given just modulus, you're going to deal with straight lines. Keep that in mind. Best way to go about it, find points. Find the scenarios where put x equal to 0 and see if y can be 0. We can see where it meets the x-axis. Whenever you have modulus, break it along the modulus lines. What do I mean by that? X greater than 1, x less than minus 1, between minus 1 and 0. F of x equal to mod x. This means f of x equal to x when x is greater than 0, equal to minus x when x is less than 0, equal to 0 when x is equal to 0. You can put either of this as greater than or equal to or less than or equal to. Imagine that modulus equation like that, reconstruct that, and then you're through. Anytime you have only modulus come in, remember you're dealing with a set of straight lines. That is very crucial. That helps. Imagine the diagram. You put a bunch of points, you can connect them with straight lines, then we are good. If the square of the 7th term in an arithmetic progression with positive common difference equals the product of the 3rd and 17th terms, then the ratio of the first term to the common differences. 7th term of an arithmetic progression, a plus 6d whole square equals a plus 2d into a plus 16d. Then we need to find a by d. A square plus 12d plus 36 equals a square, 12ad plus 2ad plus 16ad plus 32d square. A square gets knocked off. This is 36d square. Sorry. So 36d square, 32d square. So this is 4d square plus 12ad minus 18ad equal to 0, or 4d square equals 6ad. Common difference is not 0. 4d equal to 6a. We want to find a by d. This is 4 by 6, which is 2 by 3. We're told we're dealing with positive common difference. I maybe need to, I'm just thinking about why that should have been the case. I'm going to told positive common difference. I'm just thinking why that should be the case. Where are we cancelling a d square somewhere? Cancelling only a d somewhere, and we're dealing with equal to. So the ratio should be 2:3. F of x equals 5x plus 2 by 3x minus 5. G of x is x square minus 2x minus 1. X minus 1 the whole square minus 1. G of f of 3. I'm going to find f of 3 first. 5 into 3 plus 2 by 3 into 3 minus 5. 15 plus 2, 17 by 9 minus 5, 4. So that is f of 3. We're going to find f of 3, or we're going to find f of 17 by 4. It is 5 into 17 by 4 plus 2 by 3 into 17 by 4 minus 5. This is 85 plus 8 by 4 by 51. 3 into 7 is 51 minus 20. Wonderful. So this is 93 by 31, which is 3. Brilliant. F of 3 is 3. So we need to find g of 3. G of 3 is, this can be written as x minus 1 the whole square minus 2. This is 2 square minus 2, which is 4 minus 2, 2. Or x square, 3 square minus 2 into 3 minus 1. 9 minus 6 minus 1. Just substituting, being very careful about the numbers. Luckily enough, we get a 3 here. You're through. Let a1, a2, a3 till a3n be an arithmetic progression with a1 equal to 3, a2 equal to 7. So the common difference is 4. And then we have a1 plus a2 plus a3 all the way till a3n equal to 1830. What is the smallest positive integer m such that m times a1 plus a2 plus a3 till an is greater than 1830? And we can find n and then simplify and find this. It's probably going to be the simplest method, but I think the first 1/3, second 1/3, third 1/3. And so you can imagine it, reimagine it slightly differently. We might be able to solve this quickly. I think the answer would be 9 or 10, but I'm going to do this step by step. And so sum of n terms of this AP, common difference, I'm going to forget n, put 3n equal to k. And sum of k terms of the AP, k by 2, 2a plus k minus 1 into d is 1830. K by 2 into 2 into 3 is 6 plus k minus 1 into 4 is 1830. K by 2 into 6 plus 4k minus 4 is 1830. This is 2 plus 4k, 1 plus 2k. K into 1 plus 2k is 1830. And we can solve this. 2k square plus k minus 1830 is 0. 1830, we need to factorize it between k and 2k plus 1. Between two numbers reasonably close by. And so let's divide this by 6. This can be written as 6 into 305. That's far away. 305 is 61 into 5. So 30 into 61 works. So k is 30. 3n is 30 or n is 10. We need to add this till 10 terms. Let's do that. 10 by 2 into 2 into 3 plus 9 into 4. And 2a plus n minus 1 into d. So this is 5 into 6 plus 36. 5 into 42, just 210. 210 into m should be greater than 1830. 21 into m should be greater than 183. 21 into 9 is 189. 9 works. So I'm just doing it methodically, finding 3n, then finding n, then substituting and finding m. 21 into m is greater than 189, so m equal to 9 works. Ratio of a square and b square. It's a wonderful, wonderful question. A and b are integers of opposite signs, such that a plus 3 whole square is to b square is 9:1. A plus 3 whole square by b square is 9, or a plus 3 by b is plus or minus 3. Likewise, a minus 1 by b minus 1 whole square is 4, or a minus 1 by b minus 1 is plus or minus 2. Okay. Or a plus 3 is 3b or minus 3b. Right. If a plus 3 is 3b, a minus 1 is 3b minus 4. A is 3b minus 3 or minus 3b minus 3. So a minus 1 is 3b minus 4 by b minus 1, or minus 3b minus 4 by b minus 1. This is equal to plus or minus 2. This is equal to plus or minus 2. Why are we solving all of this? Because we're given squares. So what are we trying to do? We're going to find the ratios for all of these. Fine, and then see the scenarios where a and b are integers and of opposite signs. And so let's start with the first one. This one, 3b minus 4 by b minus 1. Fine, so I'm going to 3b minus 4 by b minus 1 is 2, or 3b minus 4 is 2b minus 2, b equals 2. And if you put b equal to 2, then b minus 1 whole square is 1, a minus 1 whole square is 4, a is 3 works. In this case we have substituted a is 3b minus 3, b equal to 2 gives us a equal to 3. These are integers, but they are not integers of opposite signs, so this doesn't work. If we put 3b minus 4 by b minus 1 is minus 2, we get 3b minus 4 is minus 2b plus 2, or 5b is 6, b is 6 by 5. This doesn't work because we want b and a to be integers and of opposite signs. The other equation, minus 3b minus 4 by b minus 1 is 2. So minus 3b minus 4 is 2b minus 2. Minus 3b minus 2b is minus 2 plus 4. Minus 5b is 2. b is minus 2 by 5. That doesn't work. The last variant, hopefully this will work. Minus 3b minus 4 is minus 2b plus 2. But take this as minus 2. Or minus 3b plus 2b is 2 plus 4, which is 6. b is minus 6. Fine. b is minus 6. In this case we have made the assumption that a is minus 3b minus 3. a should be minus 3 into minus 6 minus 3, which is 18 minus 3, 15. Fine. So a is 15, b is minus 6 works. 15 plus 3 square is 18 square, minus 6 square is 6 square. This is 9. 15 minus 1 is 14 square, is 2. Minus 6 minus 1 minus 7 square, this is 4. This works. 15 and minus 6 works. A square is to b square is 15 square by 6 square, which is 5 square by 2 square. 25 is to 4. This is the answer choice we're looking for. Very doable question, just that this ratio could be plus or minus 3 when you take the square root. A plus 3 by b could be plus or minus 3. A minus 1 by b minus 1 could be plus or minus 2. Plug in all 4. Only one combination where we get integer values for a and b and of opposite sign. That's the value of a and b. Plug in a square is to b square. We got 25 is to 4. Log x to the base 3 is a. Log y to the base 12 is also a, where x and y are positive numbers. If g is the geometric mean of x and y, the log g to the base 6 would be log x to the base 3 would be a, or x is 3 power a. Log y to the base 12 is a, or y is 12 power a. Geometric mean is square root of xy, which is square root of 3 power a into 12 power a, which is square root of 36 power a. Square root of 36 power a, this is square root of 6 power 2a, 6 power 2a whole power 1 by 2, which is 6 power a. So the geometric mean is 6 power a. Log g to the base 6 be a. Go back to the idea of expressing in terms of exponents, go from logarithms to exponents, and then we are through. Log x to the base 3 is a, or x is 3 power a. This step 1 in logarithms, be very comfortable with that. But 90% of the questions start and end with this. Nothing more than that. X is 3 power a, y is 12 power a, x into y is 36 power a, which is 6 square whole power a. Right? Or square root of that is just 6 power a, and then you're through. If x is a real number, such that log 5 to the base 3 is log 2 plus x to the base 5, and log 5 to the base 3 is log 2 plus x to the base 5, then which of the following is true? Log 5 to the base 3 is greater than 1. Log 3 to the base 3 is 1. 3 power a number more than 1 is this. Log 5 to the base 3 is less than 2. Log 3 to the base 3 is 1. Log 9 to the base 3 is 2. We want to find a range of x. So log of 2 plus x to the base 5 is greater than 1. Log of 2 plus x to the base 5 is less than 2. Or 2 plus x is greater than 5. 2 plus x is less than 5 square. Or x is greater than 3, 2 plus x is less than 25, or x is less than 23. 3 less than x less than 23. We're going to get a narrower range than this. Log 5 to the base 3 is much more than 1. So probably x is not just greater than 3, x is probably greater than 5 or 6. And log 5 to the base 3 is much less than 2. So x is probably less than 20 even. X might lie in a narrower range, right, between 5 and 20 or 6, and we can find the precise value of x. Right? But this is one range as a starting point. If this range satisfies only one of the answer choices fitting this range, we are through. If that's not the case, then we'll have to revisit this. And 0 less than x less than 3, that doesn't work. 23 less than x less than 30, that doesn't work. If x is more than 23, this side will become more than 2. X greater than 30, that doesn't work. This should work. This is precisely this range. We're done. Just substituting two nice endpoints, and then we are through with this question. F of x equal to x square and g of x equal to 2 power x. What is the value of f of g of x plus f of g of x plus g of f of x at x equal to 1? We're looking for let's find f of g of x plus g of f of x at x equal to 1. Then we'll worry about finding f of this. Right? So g of 1 is 2 power 1, this is 2. F of 1 is 1 square, which is 1. This number becomes f of 2 plus g of 1 at x equal to 2, at x equal to 1. And we're substituting x equal to 1. G of 1 is 2, f of 1 is 1. Right? Now f of 2 is 2 square, which is 4. G of 1 is 2 power 1, which is 2. So this sum at x equal to 1 is 6. We need to find f of 6. F of 6 is 6 square, 36. Done. Juicy, wonderful, easy question. So we would love it if all our questions were like this. Substitute x equal to 1, find this expression, be careful with the math. That's it. Nothing more than that. Sum of squares of roots. The minimum possible value of the sum of the squares of the roots of the equation is the roots p and q, the two roots, the quadratic. We want to find the minimum value of p square plus q square. We know the sum of the roots and product of the roots formulae. Sum of the roots p plus q is minus b by a, which is minus of a plus 3. PQ is c by a, which is minus of a plus 5. P square plus q square, we want to write this in terms of p plus q and pq. It will be p plus q whole square minus 2pq. This will be p square plus q square plus 2pq minus 2pq. Or this expression is going to be minus of a plus 3 the whole square minus 2 times minus of a plus 5. Or this is a square plus 6x, a square plus 6x plus 9 plus 2a plus 10. Or this is a square plus 8a plus 19. So now we want to find the minimum value of a square plus 8a plus 19. The best way to do it would be the completion of squares. A square plus 8a plus what would make this a square? Something of the form a plus k the whole square. A square plus 8a plus 16 will work. This a square plus 2ax plus 2ak plus k square. So it should be 4. A square plus 8a plus 16 plus 3. This is 19. So we write this 19 as 16 plus 3. Or this is a plus 4 the whole square plus 3. The minimum value this can take is 3. That is when a is minus 4. Or the minimum possible value is 3. Super. We want to find 9 power x minus half minus 2 power 2x minus 2 equals 4 power x minus 3 power 2x minus 3. 9 power x minus half is 9 power x by 9 power half minus 2 power 2x by 2 square equals 2 square whole power x minus 3 power 2x by 3 cube. And so 9 power x by 3, which is 3 power 2x by 3 minus 2 power 2x by 4 equals 2 power 2x minus 3 power 2x by 27. I'm going to bring the 3 powers to one side, 2 powers to one side, see where that takes us. So 3 power 2x by 3 plus 3 power 2x by 27 equals 2 power 2x plus 2 power 2x by 4. And so this is 9 times 3 power 2x plus 3 power 2x by 27 equals 4 times 2 power 2x plus 2 power 2x by 4. 3 power 2x into 10 by 27 equals 5 into 2 power 2x by 4. This 5 gets knocked off. We have a 2 here. This becomes 3 power 2x into 8 equals 2 power 2x into 27. And so think about this. This is 3 power 2x minus 3 equals 2 power 2x minus 3. This is possible only when both of these are 0, or 2x minus 3 should be 0, x should be 3 by 2. Wonderful question. A bunch of simple ideas to keep in mind. A power 9 power x minus half is 9 power x by 9 power half. Something power half is square root. And then manipulate with exponents rules, you'll get to the answer. It's a very doable question, but you'll be very methodical and understand the rules of exponents very clearly. Log of 2 power a into 3 power b into 5 power c is the arithmetic mean of log of 2 square into 3 cube into 5, log of 2 power 6 into 3 into 5 power 7, and log of 2 into 3 square into 5 power 4. Or this expression is this plus this by 3. Fine. So, or 3 times log of 2 power a into 3 power b into 5 power c is log of 2 square into 3 cube into 5 plus log of 2 power 6 into 3 into 5 power 7 plus log of 2 into 3 square into 5 power 4. Or 2 power 3a into 3 power 3b into 5 power 3c equals 2 square into 2 power 6 into 2 power 1 into 3's into 5's. We need to find only a, so forget about 3's and 5's. 2 power 3a is 2 power 9. 3a equals 9, a equals 3. It's 2 square, 2 power 6, 2 power 1. That will become 2 power 9, which is 2 power 3a. A is 3. Done. Because we don't need to find b and c, we don't worry about powers of 3 and powers of 5. A1, A2, A3, A4, A5 be a sequence of 5 consecutive odd numbers. So A1, A2, A3, so I'm going to call this as n, A3 as n minus 2, n minus 4, n plus 2, n plus 4. Consider a new sequence of 5 consecutive even numbers ending with 2A3. So this is A3 ending with 2A3. 5 consecutive even numbers. If sum of the numbers in the new sequence is 450. So I'm going to think about the new sequence as m plus 2, m plus 4, m minus 2, m minus 4. 2A3 is the last number. That happens to be m plus 4. Fine. Now adding all this, we get 450, or the middle number is 90. 5m is 90, so 92, 94. 94 is 2A3. 2A3 equals 94, or A3 is 47. This is 47, 49, 51. So A5 should be 51. The key learning here, or the only big learning here, the only important point here, if you have 5 terms in an AP, anchor it around the middle term. Average of any number of terms in AP is the middle term. Median, mean, both are the middle term. So 5 terms in AP, 5 times the middle term is sum of all terms. So sum of these 5 terms is 450, middle term is 90. Middle term is 90, that means the last term is 94. Last term is 2A3, 2A3 is 94, A3 is 47, A4 is 49, A5 is 51. How many different pairs A comma B of positive integers are there such that A is less than or equal to B and 1 by A plus 1 by B is 1 by 9? So beautiful question. A is less than or equal to B. 1 by A plus 1 by B equals 1 by 9. Think about this. Let's simplify this. If we have two numbers adding up to 1 by 9, and so we cannot have either number to be, they're talking about positive integers, we cannot have either number to be greater than 1 by 9. Very simple idea. We know that A and B are both greater than 9. And very simple idea. And so 1 by A plus 1 by B is 1 by 9. We cannot have 1 by 2 plus a positive term to be 1 by 9. That's impossible. A and B, we're talking about positive integers. A and B should both be greater than 9. Right? So the simplest idea to think about is 1 by 18 plus 1 by 18. This is 1 by 9. So A and B can be 18 comma 18. That is one possibility. Half and half equal 18 comma 18. Now A is less than or equal to B. So this number 1 by A will be high, 1 by B will be lesser. A is less than or equal to B, so this works. 1 by 18 plus 1 by 18 is 1 by 9, or A should be less than or equal to 18, B should be greater than or equal to 18. If I increase A and B, the total will become smaller. If I decrease both A and B, the total will become greater than 1 by 9. I want 1 by A plus 1 by B to be 1 by 9. That means one number equally split is 1 by 18 and 1 by 18. So we cannot have both less than 1 by 18. We cannot have both more than 1 by 18. Or this number should be that A should be less than or equal to 18. B should be greater than or equal to 9. We know A and B are both greater than 9. Right? That much we know. Right? So A should be less than or equal to 18. A should be greater than 9, or A can take values 10, 11, 12, 13, 14, 15, 16, 17, 18. 2, 3, 4, 5, 6, 7, 8, 9 possibilities. Of this, 18 works. Now we can think of 1 by b as 1 by 9 minus 1 by a. So 1 by 9 minus 1 by any of this, wherever it will become a nice 1 by b, where b is an integer. We are through. Straight away you can sense that 17 won't work. 1 by 9 minus 1 by 17. 17 minus 9 by 17 into 9. It won't factorize. That's out. 1 by 18 minus 1 by 9 minus 1 by 16. Nothing in common. Be 7 by something. Doesn't work. 15 could work. 1 by 9 minus 1 by 15. So the denominator could be 45. 5 by 45 minus 3 by 45. 2 by 45. Funnily enough, that doesn't work. 14, not likely to work. 1 by 9 minus 1 by 14. 14 minus 9 by 14 into 9, not possible. 13, 1 by 9 minus 1 by 13, won't work. 12 might work. It has to have something in factor with 9, in common with 9. 1 by 9 minus 1 by 12. 36 is common. 4 minus 3 by 36. 1 by 36. Yep, that works. A equal to 12, B equal to 36. That is a possibility. So 12 works. 11, 1 by 9 minus 1 by 11 is 2 by 99. Doesn't work. 10, 1 by 9 minus 1 by 10 is 10 minus 1, 1 by 90. That can work. 10 works. A equal to 9, B equal to 90 works. So 18 comma 18 works, 12 comma 36 works, 9 comma 90 works. Nothing else can work. A cannot be 9, B being infinity, that's not possible. So 3 pairs work. So wonderful question, tough question. A little bit of math, a little bit of trial and error. Key thing to notice here is to start with 18 comma 18 works. And after that, one of A and B has to be less than 18, other has to be more than 18. So A is less than or equal to 18, B is greater than or equal to 18. A cannot be less than 9. It cannot even be equal to 9. So from 10 to 18, that's a set of possible values A can take. Go step by step. We can forget about primes. We can forget about numbers that have nothing in common with 9. All those will just weed themselves out. Worry about the remaining. We are through. F of A comma B is F of A into F of B for all positive integers A and B. Then the largest possible value of F of 1. See, F of A into B is F of A into F of B. It's A into B. I'm going to put B as 1. F of A into 1 is F of A into F of 1. Or F of A is F of A into F of 1. Or F of A into F of 1 minus 1 is 0. There are two possibilities here. Remember this. Either F of A is 0 or F of 1 is 1. Either this could be a constant function where F of all values is 0. Then F of A into B will be equal to F of A into F of B. In which case, F of 1 will also be 0. Or F of 1 is 1. In which case there are different values possible, but F of 1 is 1. That much we know. The largest possible value of F of 1 is 1. When F of 1 could either be 1 or it could be 0. If the constant function F of A equal to 0, then F of 1 will also be 0. If that is not the case, then F of 1 is 1. The largest possible value of F of 1 is 1. Let F of x equal to 2x minus 5 and G of x equal to 7 minus 2x. Then modulus of F of x plus G of x equals modulus of F of x plus modulus of G of x, if and only if. So let's worry about this. This is easy to form. Modulus of 2x minus 5 plus 7 minus 2x equals modulus of 2x minus 5 plus modulus of 7 minus 2x. 2x minus 5 plus 7 minus 2x is modulus of 7 minus 5, which is mod 2, which is 2. Modulus of f of x plus g of x is 2. We need this to be 2. Now, modulus of 2x minus 5, modulus of 7 minus 2x. This breaks at 5 by 2. This breaks at 7 by 2. What do I mean by that? Greater than 5 by 2, we'll call it as 2x minus 5. Less than 5 by 2, we'll call it as 5 minus 2x. Fine. Likewise, 7 minus 2x goes to 0 at 7 by 2. So we'll worry about the expression being 7 minus 2x and 2x minus 7, depending on that range. 5 by 2 and 7 by 2 are our pivotal points. So our answer choice is going to be anchored around that. And so now think about this. We have 0 here, 5 by 2 somewhere here, 7 by 2 somewhere here. X is greater than 7 by 2. X is less than 5 by 2. X sits between 5 by 2 and 7 by 2. Those are our three possibilities. Right? Less than 5 by 2. If X is less than 5 by 2, X is say 2. Then this will be 2 into 2 minus 5, which is minus 1. Modulus of minus 1 is plus 1. So here there will be 5 minus 2x plus modulus of 7 minus 2x. If x is less than 5 by 2, this will stay as 7 minus 2x plus 7 minus 2x. This will be 12 minus 4x. And I'm just breaking it into three ranges. Fine. So 0 to 5 by 2, the expression will be like this. Fine. So when x is less than 5 by 2, modulus of 2x minus 5 is of the form 5 minus 2x. When x is greater than or equal to 5 by 2, modulus of 2x minus 5 will be 2x minus 5. Likewise, when x is less than 7 by 2, modulus of 7 minus 2x will be 7 minus 2x. When x is greater than or equal to 7 by 2, modulus of 7 minus 2x will be 2x minus 7. Fine. So this is how this function breaks. Therefore, if we are looking at 0 to 5 by 2, 5 by 2 to 7 by 2, greater than 7 by 2. And 0 to 5 by 2 we have done. Now we are going to think about not 0 to 5 by 2, less than or equal to 5 by 2. Then this expression becomes 12 minus 4x. We're going to talk about 5 by 2 less than x less than 7 by 2. In this range, the expression will be x is more than 5 by 2. This will be 2x minus 5. X is less than 7 by 2 plus 7 minus 2x. This is 2. X is greater than or equal to 7 by 2. This will become 2x minus 5 plus 2x minus 7, which is 4x minus 12. So here it is 2. Fine. In these two ranges, it doesn't work. Fine. So the answer looks like it is this, but we have to be very careful here. When x is equal to 5 by 2, 12 minus 4 into 5 by 2 is also 2. It's equal to 7 by 2, 14 minus 12, that also works. So this right here is not the answer choice. This is the answer choice. X could be 5 by 2, x could be 7 by 2. Both are possible. So x lies between 5 by 2 and 7 by 2, all right. But it is close to interval 5 by 2 to 7 by 2. Both of those values are indeed possible. So worry about this. Don't do all this and mark this as the answer choice. It's a wonderful, wonderful question. So 5 by 2 less than x less than 7 by 2. That works. This range works. That is if x is there, but only if, then you have to mark this. Because x could be 5 by 2, x could be 7 by 2. That possibility also needs to be considered. So keep that in mind. An infinite geometric progression a1, a2, a3 has the property that an equals 3 times an plus 1 plus an plus 2 and so on. Infinite terms. For every n greater than or equal to 1. a1 plus a2 plus a3 all the way till 32. Sum of infinite terms of a1 is 32, or the first term being a by 1 minus r is 32. Fine. A equals 3 times a2 plus a3 and so on. This is also an infinite sequence. In this expression, I am putting n equal to 1. a2, this is geometric progression with the first term being ar and the sequence being 1 minus r, or this is a equals 3 times a into r by 1 minus r, or 1 minus r equals 3r, 1 equals 4r, r equals 1 by 4. A by 1 minus r is 32. A equals 32 into 1 minus 1 by 4. A is 32 into 3 by 4, which is 24. We want to find A5. A5 is AR power 4. A5 equals AR power 4. A is 24. R power 4 is 1 by 4 whole power 4. So this is 24 into 1 by 4 into 1 by 4 into 1 by 4 into 1 by 4. 24 by 4 is 6. This is 2, 3. This is 3 by 2 into 4 into 4, 3 by 32, wherever the choice is. A1 is 1 by 2 into 5, A2 is 1 by 5 into 8, A3 is 1 by 8 into 11, all the way till A100. And so, how do we do this? This is going to be something of this form. Finally, you have to sense this: A minus B plus B minus C plus C minus D, all the way till something. So a bunch of terms are going to get cancelled, and we're going to be left with something in the end. The method, getting a sense of the method is very important. We're going to somehow fall back into the idea of partial fractions. And so if you can sense that, that is brilliant. Fine. So first up, we need to find the 100th term. This is 1 by 2 into 5, 5 into 8, 8 into 11. We're going plus 3, plus 3, plus 3. So A1 is 2 into 5, A2 is 5 into 8. So I'm going to define AN as 1 by n plus 1 into n plus 4. So A2 is, 5 into 8. This goes up in steps of 3. 1 by 3n minus 1 into 3n minus 3n plus 2. This is AN. First term is 1 by 2 into 1 by 5. Why 3n? Because this goes up in steps of 3. So these are anchoring around multiples of 3. I'm going to link A1 to 2, A2 to 5, A3 to 8. What is this sequence? This is 3 minus 1, 6 minus 1, 9 minus 1. So this first term is 1 by 3n minus 1. Second term is this plus 3, 3n plus 2. Right? And so on. So 100th term will be 1 by 3 into 100 minus 1. 3 into 100, 300 minus 1, 299 into 302. That's the 100th term. We're going to break this open using the idea of partial fractions. How so? Start with, I'm going to go back to this. Let's get back to pointer mode. 1 by 2 into 5. So I'm going to think about it as 1 by 2 minus 1 by 5. LCM is 2 into 5. Numerator is 5 minus 2. 3 by 2 into 5. 1 by 5 minus 1 by 8. 5 into 8. 8 minus 5, which is 3 by 5 into 8. Or imagine this like this: 1/3 of this will be 1/3 of this, which is 1 by 2 into 5. 1/3 of this will be 1/3 of this, will be 1 by 5 into 8. Or this giant expression can be written as 1/3 whole of 1 by 2 minus 1 by 5. Plus 1 by 5 minus 1 by 8 plus 1 by 8 minus 1 by 11, all the way to 1 by 299 minus 1 by 302. Right? Just like how we had outlined, A minus B plus B minus C plus C minus D plus D minus C, all the way till one final term. Bunch of things get cancelled. This will get knocked off, this will get knocked off, this will get knocked off. Everything will get knocked off till there. Or we are looking at 1 by 3 times 1 by 2 minus 1 by 302. 302 and 2, LCM will be 302. This will be 151. So this is 1 by 3 times 151 minus 1 by 302. This is 1 by 3 times 150 by 302. This is 50 by 302, or 25 by 151. Just this choice. Fine. key thing here, you're looking at partial fractions. You're looking to break these into fractions such that you have a bunch of terms that get cancelled. 1 by 1 into 2 is 1 by 1 into 1 by 2. 1 by 2 into 3 is 1 by 2 minus 1 by 3. 1 by 3 into 4 is 1 by 3 minus 1 by 4. Likewise, 1 by 2 into 5 is 1 by 2 minus 1 by 5. 1/3 of this. The numerator becomes 3. So I'll have to knock that off. So this whole expression becomes 1/3 of 1 by 2 minus 1 by 5, 1 by 5 minus 1 by 8, 1 by 8 minus 1 by 11, all of those added. So a bunch of terms will get cancelled. We'll be left with 1/3 of 1 by 2 minus 1 by 302. That is 151 by 302 minus 1 by 302, or 150 by 302, 1/3 of that. 50 by 302, which is 25 by 151. P cube equal to q power 4 equal to r power 5 equal to s power 6. The value of log of PQR to the base s. These kind of questions I would usually like to plonk this as equal to k power something, so that everything we can get in terms of k, and then this we can write it as log PQR by log s both to the base k. That is the approach. You get that, you're through. Equal to k power what? That is the key thing. We want this to be a multiple of 3, 4, 5 and 6. LCM of 3, 4, 5 and 6 is LCM of 4, 5 and 6. LCM of 4 and 6 is 12. 12 and 5 is 16. Or P equals k power 20, Q equals k power 15, R equals k power 12, S equals k power 10. Log of PQR to the base k by log s to the base k. So it's log of k power 20 into k power 12 into k power 15. P, R and Q, I've written it incorrectly, by log of k power 10 to the base k. This is simple. 20 plus 12 is 32. 32 plus 12 is 47. 47 by 10. This is the answer. The moment we plonk it like this, then we get everything in terms of one variable. An old trick, suppose you're told 2a equals 3b equals 4c equals 5d. Plonk this all to be equal to 60 k, and then get everything in terms of k. Nice whole numbers, nothing to worry about, you're done. Fine. So this is an old trick for simplifying variables. You've given bunch of equations, assume a new variable, life becomes simple. The area of rectangle and the square of its perimeter and are in the ratio 1:25. L into B is to 2 times L plus B whole square is 1:25. I'm going to write down this equation and then figure this out. LB is to 2 times L plus B whole square is 1:25. We need to find the ratio B is to L, shorter to longer side. And so L is to B, L into B equals 4 times L square plus 2LB plus B square is 1:25, or LB is to 4L square plus 8LB plus 4B square is 1:25, or 25LB equals 4L square plus 8LB plus 4B square. 4L square minus 17LB plus 4B square is 0. Can be split as 16 and 1. They're going to get a ratio of 1:4. Fine. So 4L square minus 16LB minus LB plus 4B square is 0. 4L into 4L minus 4B minus B, sorry, 4L into L minus 4B minus B into L minus 4B is 0. So 4L minus B into L minus 4B is 0. 1:4 or 4:1. Shorter to longer is 1:4. When just plain old-fashioned writing of equations, simplifying that, you're looking to solve for b by l. If you want to deal with only one variable, you don't like factorizing like this, divide by l square throughout. So you'll get 4 minus 17b by l plus 4b by l whole square equal to 0. b by l is what we want to find. We'll have 4 minus 17x plus 4x square equal to 0. X is what we need to find. You can simplify and find that. If you don't like dealing with a quadratic equation that has L and B, then create a B by L by dividing by L square throughout, and then you're done. You're dealing with only one variable. 4 power n is greater than 17 power 19. I'm going to write this as 4 square power n by 2 is greater than 17 by 19. 16 power n by 2 is greater than 17 power 19. We want to find the smallest n. I'm going to think about n that doesn't work. If I put n, 16 power 19 is not greater than 17 power 19. 16 power 38 by 2 is not greater than 17 power 19. N cannot be 38. 38 does not work. N has to be greater than 38. So 33 doesn't work, 37 doesn't work, 35 doesn't work. Bam, we've got this. We need to now think that 16 power 39 by 2 is greater than 17 power 19. Fine. It should be, I'm not saying it is not. This is 4 into 16 power 39 is greater than 16 power 19 is greater than 17 power 19. 4 is greater than 17 by 16 whole power 19. This could be tough to prove. It should be. That's what the question is telling us. But we do not have to worry about it. We know that 38 doesn't work. If the 39 and 40 had been in the choices, then we are worried. We are in trouble. It's not. So this becomes an easy question. 39 works. N cube minus 11n square plus 32n minus 28 greater than 0. The smallest integer n. See, n cube is powerful. So if you put 100, then n cube will kill everything else. These are reasonable coefficients. And n cube is very powerful. So if n cube is positive, n cube is way more powerful than n square, way more powerful than n. So if you put n cube as 7, 8, 9, 10, 11, the larger you take n cube to, the more dominant the cube idea will become. So this is going to become bigger and bigger the more the higher n gets. And it's a curve that's open-ended. It's going to become larger and larger with increasing n. We can sense that. And there are multiple ways of doing this. One would be to just plonk in a value of n and then go from there. My favorite is probably n equal to 10. This is 1000 minus 1100 plus 320 minus 28. 1000 minus 1100 minus 100 plus 320 minus 28. So this works. Now maybe 9 will work, maybe 8 will work. I would like to skip to 8 and then come back and check 9. If 8 works, then I can go lower. So this is 512 minus 11 into 64 plus 32 into 8 minus 28. So 512 minus 704 plus 32 into 8. This is 256 minus 28. So 512 plus 256 is 867. 704 plus 28 is 732. So 512 plus 256 is greater than 704 plus 28. So 8 works. Already I'm beginning to sense that 7 won't work. When so 8 works, this is this close. So the more dominant n is, n cube is, larger numbers should be higher. 8 works and 8 is this close, so 7 probably won't work. Let's check it out any which way. So 343 minus 11 into 49 plus 32 into 7 minus 28 greater than 0. Is this true? 49 into 11, 490 plus 49 is 539. So 343, 5, 39, 28, 32 into 7, 7 2s are 14, 4, 1, 7 3s are 21 plus 1, 22. Let's add these through. 3 plus 4 is 7, 4 plus 2 is 6, 567. I have a gut feeling this will be 567. So 7 is equal to 0. 8 works. An increasing sequence. So the smallest integer that works is 8. The other way of thinking about it is substituting small values and seeing if it can something factorize it. So p of x by x minus a remainder is 0. So we can look to factorize this if we can manage to find a factor. So we have n cube minus 11n square plus 32n minus 28. If you put n equal to 1, 1 minus 11 plus 32 minus 28. This adds up to 39, it adds up to 33, doesn't work. 2, 8 minus 44 plus 64 minus 28. 72, 72, yeah, this works. So this number, n cube minus 11n square plus 32n minus 28 is a multiple of n minus 2. We can factorize this. N square goes here, n cube minus 2n square. So minus 9n square plus 32n minus 9n minus 9n square plus 18n. We'll have 14n minus 28 plus 7. Sorry, plus 14. This is 14n minus 28, or our expression is n minus 2 into n square minus 9n plus 14, or it is n minus 2 into n minus 2 into n minus 7. When will this be greater than 0? When n is greater than 7. When n is 7, it will be greater than 0. When n hits between 2 and 7, it will be negative. What happens when n is 1? Very interesting. When n is 1, this 1 cube minus 11 plus 32 into 1 minus 28. 1 minus 11 plus 32 minus 28. This is 33 minus 39, which is minus 6. This doesn't work when n is 1. When n is 3, 4, 5, it won't work. When n is 1, these two are negative, this is negative. All three are negative, it doesn't work. Between 3 and 7, it doesn't work. These two will be positive, this is negative. The smallest integer that will work for is the integer 8. So sum of the squares of two numbers is 97. Then which of the following cannot be their product? A square plus b square equals 97. Fine. Very interesting. Here we're talking about AB. And very interesting. So think about this. A square plus b square and AB. That's a very powerful link. If you think about 2 times AB. AB is 64. That means 2AB should be 128. 2AB should be minus 64. 2AB should be 32. 2AB should be 96. Why am I doing this? Because I can think about a square plus b square plus 2ab, a square plus b square minus 2ab. When a square plus b square plus 2ab should be greater than or equal to 0, because this is a plus b whole square. A square plus b square minus 2ab should be greater than or equal to 0. This is a minus b whole square. 97 plus 128 works. 97 minus 128 does not work. It cannot be 64. The rest it can be. Quite simply put, a square plus b square should be greater than or equal to modulus of 2ab. A square plus b square should be greater than or equal to 2ab. It should be greater than or equal to minus 2ab. That's the condition. A square plus b square by 2 is greater than or equal to a into b. Modulus of a into b all the time. And so this idea is very important, very useful. So here it is summing up to 97. So 2ab has to lie between 97 and minus 97, or AB should be less than 97 by 2, greater than minus 97 by 2. All of these work, this one doesn't. So that's all we need to keep in mind for this question. If A and B are integers important, such that 2x square minus ax plus 2 is greater than 0, and x square minus bx plus 8 greater than or equal to 0, for all real numbers x, very vital point, is always greater than 0. Then the largest possible value of 2a minus 6b. It's a complicated sounding question. We're going to do this by a wonderful method called as completion of squares. What do I mean by that? Let's take this one. 2x square minus ax plus 2 greater than 0. I don't want to deal with 2x square. I'm going to think of this as x square minus a by 2x plus 1 greater than 0. We know that x minus k the whole square, x square minus 2kx plus k square. And here we have an a by 2, right? That is equal to 2kx, or we're talking about k equal to a by 4. That's when this will match. That means k square should be a square by 16. What do I mean by that? Suppose this were x square minus a by 2x plus a square by 16. This is x minus a by 4 the whole square. And I cannot just add on one side. So I'll add a square by 16 at this side also, and then bring this plus 1 this side as minus 1. Or x minus a by 4 whole square is greater than a square by 16 minus 1. Now remember, this is always true. This will always be true only if this is negative or 0. Right? So this always holds good. That means this expression has to be negative or 0. X minus a by 4 whole square is greater than 4 will not always hold good. X minus a by 4 whole square is greater than minus 3 will always hold good. Or a square by 16 minus 1 should be less than 0. It cannot even be equal to 0. Because if this were equal to 0, then x minus a by 4 the whole square is always greater than 0. That won't hold good, because if x is a by 4, this will become 0. And this number should be negative. Or a square is less than 16. A is in the range minus 4 to plus 4. Fine. So we want the largest possible value of 2a minus 6b. So a has to be as high as possible. A cannot be 4, or a should be 3. So I'll jump in and do the same thing for b. X square minus bx plus 8 is greater than or equal to 0. Wonderful. There's a greater than or equal to here. This is x square minus bx plus b square by 4 greater than or equal to b square by 4 minus 8. Why are we adding b square by 4? B square by 4 is b by 2 whole square. 2 times b by 2 is b. So this becomes x minus b by 2 whole square is greater than or equal to b square by 4 minus 32 by 4. Remember, this always holds good for all real values of x. That means b square should be less than or equal to 32. Here it is less than or equal to, but that doesn't matter because we're looking only at integers. That means b square can go from minus 5 to 5. But it's greater than 5, it will become 36. Minimum of 36. If it's less than minus 5, it will be minimum of 36 again. So minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. All of these will work. We want 2a minus 6b to be very high, or we want b to be very small. The smallest integer b can take is minus 5. 2 into 3 minus 6 into minus 5 is the largest possible value of 2a minus 6b. 6 plus 30, which is 36. The key takeaway here, the most important point here, is the idea of completion of squares. You might be given any quadratic equation, x square plus 5x plus 11. You should be able to write it as x plus a whole square plus b. find suitable A and B such that this becomes like this. Be it with numbers or variables, it doesn't matter. Any quadratic, you should be able to write it as a square plus a constant, an adjusting term. You should be able to do that. That is very vital. Add that to your list of skills today. Do it a lot of numbers. Anything, x square plus 23x minus 139. Write it as some x minus k the whole square plus m. Or if you have x square plus px plus q, write it as some x plus something the whole square plus an adjusting term. That skill is vital. A is 6 power 2n minus 35n minus 1, n equal to 1, 2, 3, and B is 35 times n minus 1, n is 1, 2, 3. And which of the following is true? Neither every element of A is in B, nor every member of B is in A. Every member of A is in B, and at least one member of B is not in A. Every member of B is in A. B is a subset of A. At least one member of A is not in B. Whereas A is not a subset of B. Right? This says A is a subset of B. Before we go further, I want to write down and see a few numbers. I want to put n equal to 1. So 6 square minus 35 minus 1, which is 0. We put n equal to 2. 6 power 4 minus 70 minus 1. N equal to 3. 6 power 6 minus 105 minus 1. There are going to be some numbers. I can already sense that A becomes larger and larger the more we put, because it goes 6 square, 6 power 4, 6 power 6, 6 power 8. A runs away from us, becomes bigger and bigger. And B, when n equal to 1, B is 35 times n minus 1. 35 times 0, B would be, B, the first element will be 0. When n is 2, it is 35 into 1, 35. When n is 3, 35 into 2, 70. B is more predictable. Every multiple of 35 from 0 onwards, every positive multiple is there in this set. Now, this question just opens up because of this. Neither every member of A is in B, nor every member of B is in A. Every member of B is in A. This is wrong. 70 is not in A. A is galloping away. At least one member of A is not in B. So all multiples of 35 are sitting here practically, including 0, all positive multiples. All we've got to think now is, are these numbers multiples of 35? That's all we need to think. And they have to be. Why so? Think about this. A is 6 power 2n minus 35n minus 1. I'm going to write it as 6 power 2n minus 1 minus 35n. This is 36 power n minus 1 power n minus 35n. 36 power n minus 1 power n will be a multiple of 36 minus 1. So every element in A is a multiple of 35. B lists all multiples of 35, including 0. So every element of A is in B. And at least one member of B is not in A. 70 is not in A. 105 not in A. A jumps across multiples of 35. After 0, it goes to a large number, and then a much larger number, and then a giant larger number. B lists every multiple of 35. So B is a superset. A is contained within that. There's A like this and B like this. Every element of A is in B, and at least one member of B is not in A. There are plenty of members in B. 1 by log 100 to the base 2 minus 1 by log 100 to the base 4 plus 1 by log 100 to the base 5. And all of this, I'm going to rephrase this. 1 by log A to the base B is log B to the base A. This is log 2 to the base 100 plus minus log 4 to the base 100 plus log 5 to the base 100, etc, etc, etc. Or I'm not going to write everything down because I'm already sensing this. Log A minus log B is log of A by B. Everywhere the base is going to be 100, or we are looking at log of 2 into 1 by 4 plus 5 into 1 by 10 plus 20 into 1 by 25. Sorry, 2 into 1 by 4 into 5 into 1 by 10 into 20 into 1 by 25 into 50. 50 all to the base 100. 50 by 25 is 2. 20 by 10 is 2. 2 into 2 is 4, which disappears with this, or this is log 10 to the base 100, 1 by 2. Done. Very simple idea. Log a to the base b is 1 by log b to the base a. That's all we are using, nothing more than that. And log x minus log y is log of x by y. F of x is maximum of 5x and 52 minus 2x square. Maximum of this. So this is a curve, this is a curve, this is a maximum of this. The minimum possible will be the time when the two curves intersect. Or 5x equals 52 minus 2x square. 2x square plus 5x minus 52 equal to 0. 2x square plus 5x minus 52 is equal to 0. This is what we get. We need to factorize this. 2x square, 2 into 52 is 104, so 13 and 8. 2x square minus 8x plus 13x minus 52 equal to 0. 2x into x minus 4 plus 13 into x minus 4 is 0. Or x is either minus 13 by 2 or 4. And one of these two is the answer. There are 2 points this intersects, these two curves intersect. So let's put x is minus 13 by 2. So 5 times x is 5 into minus 13 by 2, which is minus 65 by 2. 52 minus 2 times 13 by 2 minus 13 by 2 the whole square, or this is 52 minus 2 into 169 by 4. This is 2. 52 minus 169 by 2, that should be minus 65 by 2. I need not have done all this, the two values are equal. So when x is minus 13 by 2, we get minus 65 by 2. That is f of x. When x is 4, 5 times x is 20. 52 minus 32 is 20. F of x will be 20. So when at 4 and minus 13 by 2, they are equal. At minus 13 by 2, the value of f of x is minus 65 by 2. That's the answer we are looking for. How many two-digit numbers with a non-zero digit in the units place are there, which are more than thrice the number formed by interchanging the positions of its digits? xy, yx. We told this is not 0. This is definitely not 0. Otherwise, it won't be a two-digit number. The two-digit number xy is greater than 3 times the two-digit number yx. Or 10x plus y is greater than 3 times 10y plus x. 10x plus y is greater than 30y plus 3x. Or 7x is greater than 29y. X is greater than 29 by 7y. 29 by 7 is a little more than 4. So x is greater than 4y. Right. So we're looking at two digits where x is greater than 4y, little more than 4y. So we'll have to be a little careful with the numbers. If you put y equal to 1, x greater than 4y, x could be 5. So we could have 51. One number being 51, other number being 15. 51 is greater than 3 times 15. This works. 61, 3 times 16. This will work. 71, 81, 91. All of these will work. Let's just check 41 as well. 41 and 14. 14 into 3 is 42. This doesn't work. These 5 numbers work. We could put y equal to 2. 4 times y is 8. 82 and 28. 82 and 28 does not work. 28 into 3 is 84. 92 and 29, that works. With y equal to 2, there's only one possibility. 92 greater than thrice 29. Y could be 3, but y is 3. X should be more than 4y. That's not possible. Or there are 1, 2, 3, 4, 5, 6 numbers. This is what we are looking for. Find f of 10. F of x plus 2 is f of x plus f of 1. F of x plus 1. So we put for all positive integers x. F of 11 is 91. 15 is 617. We need to find f of 10. F of x plus 2 is f of x plus f of 1. So f of 1 plus f of 2 is f of 3. F of 2 plus f of 3 is f of 4. F of 3 plus f of 4 is f of 5. That's how this goes on. We know f of 11. So let's start with f of 11. F of 11 plus f of 12 is f of 13. F of 12 plus f of 13 is f of 14. F of 13 plus f of 14 equals f of 15. We know this is 91. Let's say this is x. This will be 91 plus x. This is x. This is 91 plus x. This is 91 plus 2x. This is 91 plus x. This is 91 plus 2x. Adds up to 617. Or 91 plus 91, 182 plus 3x is 617. 3x equals 617 minus 182, which is 5. 11 minus 8 is 3. 5 minus 1 is 4. 3x is 435. X is 435 by 3, which is 1, 4, 5. 145. So x is 145. We need to find f of 10. F of 10 plus f of 11 is f of 12. So this number plus 91 equals 145, or this number is 145 minus 91, which is 54. F of 10 should be 54. We'll do a very quick check. F of 10 is 54 plus 91 is 145. 91 plus 145. F of 11, f of 12 should add up to f of 13. 6, 3, 1, 236. 145 plus 236 should be 6 plus 5 is 11, 1, 1, 4 plus 4, 8, 2 plus 1, 3. 236 plus 381, 7, 1, 6, 17. This works. Obviously, we don't need to do this. In an exam point of view, we should be confident enough to mark 54 and then move on. I'm just doing this because we can verify. Nothing more than that. While multiplying three real numbers, let's say A, B, C, Ashok took one of the three numbers as 73 instead of 37. Say C, he takes as 73. He should have taken it as only 37. The product went up by 720. So AB into 37 is what he should have done. AB into 73 is what he did. The difference is 720. Or A into B into 36 is 720. A into B is 20. Then the minimum possible value of the sum of the squares of the other two numbers. So minimum possible value of A square plus B square. AB is 20. A square plus B square by 2 is greater than or equal to AB. Arithmetic mean of two numbers is greater than or equal to geometric mean. A square plus B square is greater than or equal to 2AB. Or A square plus B square is greater than or equal to 40. The minimum possible value of the sum of the squares is 40. A square plus B square has to be greater than or equal to 40. A square plus B square is greater than or equal to 2AB. This is because A minus B whole square is greater than or equal to 0. And wonderful question. First up, finding this 20 is easy. Product of two numbers is 20. Right? So it could be 1 and 20, 2 and 18, 2 and 10, and so on. And then we find A square plus B square. Right? So it will be best when they are root 20 and root 20. A square plus B square will be 20 plus 20, 40. The trial and error method, that is another way of thinking about this. Again, a wonderful question, very challenging question. Fine. So if x is a positive quantity such that 2 power x equals 3 power log 2 to the base 5. We're dealing with exponents and we're dealing with logs. One of my favorite tricks for a question like this is take log on both sides. Log of 2 power x is log of 3 power log 2 to the base 5, or x log 2 is log 2 to the base 5 times log 3. We can choose any base and this rule would work. I'm going to choose the base as 3. Why so? Because log 3 to the base 3 is 1, or x times log 2 to the base 3 is log 2 to the base 5. Fine. Or x by log 3 to the base 2 is 1 by log 5 to the base 2. Or x is log 3 to the base 2 by log 5 to the base 2. In other words, our number x is log 3 to the base 5, which is not this, which is not this. It should be one of these two. Let's see this. Let us 1 plus log 3 to the base 5 minus log 5 to the base 5. This choice will become 1 plus log of x by y is log x minus log y. Log 3 to the base 5 minus log 5 to the base 5. This goes away. Log 3 to the base 5, which is what it should be. Choice B. Wonderful question. Very tough question. Very interesting question. The choice also is interestingly phrased. Key point, whenever you're given log and exponent, it helps to simplify by taking log on both sides. Once you have taken log on both sides, choose a suitable base. Find the right base in order to be able to simplify that. Wonderful question. Again, a very, very tough question. So let's discuss this seriously. So log 81 to the base 12 is p. Then 3 times 4 minus p by 4 plus p is equal to log 3 to the power 4 base 12 is p. 4 times log 3 to the base 12 is p, or log 3 to the base 12 is p by 4. A big question, because we've got something in terms of p. We can get p in terms of logarithms and then simplify. But this p by 4 is a very interesting number, because this can be written as 3 times 4 minus p by 4 by 4 plus p by 4, or 3 times 1 minus p by 4 by 1 plus p by 4. This is wonderful, because we know p by 4 is log 3 to the base 12. So this number becomes 3 times 1 minus log 3 to the base 12 by 1 plus log 3 to the base 12. So it's 3 times 1 minus log 3 to the base 12 is log 12 to the base 12 minus log 3 to the base 12 divided by log 12 to the base 12 plus log 3 to the base 12. This is 3 times log 4 to the base 12 by log 36 to the base 12, which is 3 times log 4 to the base 36, or it is log of 64 to the base 36. So it is not this, this is not this, it is one of these two. 64 to the base 36, is it 16 to the base 6 or 8 to the base 6? This is log of 8 square to the base 6 square, which is nothing but log 8 to the base 6. Very, very tough question. Got to manipulate this on multiple iterations. It is time consuming, and you've got to pick the right logics. You need to be able to rephrase p, not just directly substitute p here and simplify. So it's got to be very careful with the computation. U square plus u minus 2v minus 1 the whole square equals minus 4vu plus v. It's a very tough question. When just u and v and only one equation and a quadratic thrown in for good measure. But if you look at the choices, these are all numbers. So there's something here that we need to crack. Right? So first up, let's expand this. A plus B plus C whole square is A square plus B square plus C square plus 2AB plus 2BC plus 2CA. If you didn't know this also, we could have just multiplied it and got to the answer. This is not a deal breaker, right? So let's plug this in. The left hand side is U square plus U square plus 4V square plus 1. U into minus 2V is minus 2UV. So minus 4UV minus 2U plus 4V equals minus 4VU minus 4V square into minus 4UV minus 4UV gets cancelled. So this is 2U square plus 4V square minus 2U plus 4V plus 4V square plus 1 equal to 0. I'm bringing everything onto the same side. And so now the interesting part here, straight away, the moment you see this and see the choices, you've got to have a sense of the method. The method here is completion of squares. Fine. Straight away, I've got to say I'm going to deal with two quadratic in some form, either a U plus V whole square or a U minus 2 plus V plus 2 the whole square. There's a UV term, you're dealing with U plus 2V or U minus 2V the whole square, something like that. There are no UV terms. The U's come together, the V's come together, and then we try to simplify. And that's important to kind of register that. Otherwise, it becomes an impossibly tough question. Right? Now think about this. So let's carve out the U together. So it is 2U square minus 2U. Let's carve out the V together. 8V square plus 4V. Added together, these add up to minus 1. Right? So 8V square is not anything square. Fine. 2V the whole square is 4V square. U square is root 2U the whole square. So I'm going to take out a 2 from here and a 2 from here and then try to simplify this. So what have we got here? 2 times U square minus U plus 2 times 4V square plus 2V equals minus 1. Right? U square minus U is part of U minus 1 by 2 the whole square. U square minus half into 2 into U, which becomes U. So this is U square minus U plus 1 by 4. So there are plus 1 by 4 sitting inside. Then this becomes a nice square. I'm adding 1 by 4. So I should add 1 by 4 this side as well. It's not just 1 by 4, it's 1 by 4 into 2. I'm adding that 1 by 2 here. Exact same funda here. We have 4V, that is 2V plus something, the whole square is 4V square plus 2V plus something. 2V into 1 is 2V. So 2AB term will have 4V. We have only a 2V here. So this should be plus 1 by 2 to have a 2V term here. Once again, we are adding 1 by 4 inside like this. That means it's a half. I add a half. Wonderful. I completely relish the fact that this boils down to 0. You'll see why. This is nothing but 2 times U minus half the whole square plus 2 times 2V plus half the whole square equal to 0. Something square plus something square is 0. A square cannot be negative. That means this is equal to 0. This is equal to 0. Or U is half. V is minus 1 by 4. 2V is minus half. V is minus 1 by 4. So we want to find U plus 3V, that is 1 by 2 minus 3 by 4, which is minus 1 by 4, which is this value. Absolutely wonderful question. First up, we'll need to expand and simplify. Bring everything to one side equal to 0. Pick the idea that we're dealing with completion of squares. Whenever you're dealing with quadratic, the completion of squares idea should be there at the back of your mind. Right? So anytime you have quadratic expressions, there are only two tricks, major tricks in your rule bag. First one is factorizing. Second one is completion of squares. One of these two will come of use generally. If you cannot square factorize, look to complete the squares. And so if we complete the squares, this giant expression is nothing but this. And then you're through. Incredibly tough question. You probably better advise skipping this question in the exam, which is something I did not do. I spent time trying to crack it. I knew fully well I was looking for something like this. Messed up my algebra, so didn't get it, and then lost a lot of time. Otherwise, wonderful question. Let x, y, z be three positive real numbers in geometric progression. Lovely, positive real numbers. That usually simplifies questions. In a geometric progression such that x less than y less than z. Y by x equals z by y. Xz equals y square. This is a common ratio. 5x, 16y and 12z are in arithmetic progression. So 5x, 16y, 12z. 16y minus 5x equals 12z minus 16y. 16y plus 16y equals 12z plus 5x. 32y equals 12z plus 5x. Now we need to find the common ratio. So I'm going to assume the common ratio to be r. If assuming the numbers as x, xr and xr square, I'm going to anchor around y. So the first term would be y by r. Second term, the third term would be yr. X is y by r, z is yr. So we can simplify this. We can say 32y equals 12yr plus 5y by r. Cancelling y, we'll get 32 equals 12r plus 5 by r. Multiply by r, 32r equals 12r square plus 5. 12r square minus 32r plus 5 equal to 0. 12r square minus 30r minus 2r plus 5 equal to 0. 6r into 2r minus 5 minus 1 into 2r minus 5 is 0. 6r minus 1 into 2r minus 5 equals 0. R is either 1 by 6 or 5 by 2. Now this comes into the picture finally. X less than y less than z. So it's an increasing GB. So the terms become larger and larger. That means the common ratio should be greater than 1 because we're dealing with positive real numbers. A positive real number multiplied by a number greater than 1 will become bigger. If it is multiplied by a number less than 1, it will become smaller. Right? So x less than y less than z, that tells that the common ratio is not 1 by 6 but 5. F of x equal to minimum of 2x square and 52 minus 5x, where x is any positive real number. And the maximum possible value of f of x. F of x is minimum of these two. We want to find maximum value of f of x. Simplest way to do it is to equate this. 2x square equals 52 minus 5x. 2x square plus 52, or sorry, 2x square plus 5x minus 52 is 0. 2 into 52 is 104. This is 2x square minus 8x plus 13x minus 52 is 0. 2x into x minus 4 plus 13 into x minus 4 is 0. 2x plus 13 into x minus 4 is 0. X is some minus 13 by 2 or x is 4. Talking about positive real number, x should be 4. Substitute that. You're talking about x as being minimum value of 2 into 4 square, comma 52 minus 5 into 4. This is 32. This is 32. Or the value we are looking for is 32. Now think about this. I'm going to dive deeper into this minimum idea. 2x square is a graph like this. 52 minus 5x is a line like this. So if f of x is a minimum of these two, we're talking only positive territory, so we completely forget this. F of x would be like this till this point, and then take this. It'll take one arc till a point and then the other arc after that. This will be the maximum value f of x can take, which is why we find a meeting point of the two arcs. Another fabulous question and very tough question. Another question that I tried during the exam and did not get right and spent a lot of time kind of doing some utterly random stuff. x bar 2018 into y bar 2017 is 1 by 2. X bar 2016 into y bar 2019 is 8. Whenever you have equations of form 2x plus y, 2x minus 5y, stuff like that, then adding or subtracting equations works. Whenever dealing with x square into y cube, x by y, then multiplying or dividing works better. So either we multiply these two equations or we divide one by the other. So the powers get added, that makes life simpler. If we multiply these two, it will become x bar 4034 and y bar 4036. Two different parts. I don't like that. Suppose we divide one by the other, this becomes x square by y square, both same part. That is lovely. So let's divide one by the other. X square by y square equals 1 by 16. X plus y, the whole square, is 1 by 16. X by y is 1 by 4. For a second I'm going to pretend that minus 1 by 4 is not possible and then worry about that later on. When x by y is 1 by 4. Now simplifying, this gives us y equals 4x. Now let's substitute that in one of the two equations. Let's substitute in the second one. X bar 2016 into 4x bar 2019 is 8. X bar 2016 into x bar 2019 into 4 bar 2019 is 2 cube. It is 2 cube. I'm going to write this as 2 square. X bar 2035 into 4035 into 2 bar 4038 is 2 cube. Lovely. But this has an x bar 4035. If I take this side, we'll get x bar 4035 equals 2 bar minus 4035, or x equals 1 by 2. Y is 4 times this, or y is 2. X square plus y cube is what we need to find. X square plus y cube. So x square is 1 by 2 whole square, which is 1 by 4. Y cube is 2 cube, which is 8. 8 plus 1 by 4. 32 by 4 plus 1 by 4. 33 by 4. Now for the negative part, we know that x bar 2018 is positive. X bar 2016 is positive. So y has to be positive. But x could have been technically plus half or minus half. Remember, we're not dealing with x, we're dealing with x square, so it doesn't really matter. This will continue. This is a and b and log this, and we want to find a plus b. It's a seemingly tough question, but it's not so. This is a very simple, very nice question. We need to know that log p to the base q is r. Log of something to the base 2 is 3, or that something is 2 cube, which is 8, or log a to the base 3 is 8 minus 5, which is 3, or a is 3 into 3, which is 27. Likewise, for this part, log something to the base 5 is 3, or that something 4a plus 12 plus log b to the base 2 is 5 cube, which is 125. 4a is 27 into 4. 27 into 4 is 108. 108 plus 12 is 120, plus log b to the base 2 is 125, or log b to the base 2 is 5. Sorry, log b to the base 2 is 5. B is 2 power 5, which is 32. A is 27, b is 32. A plus b is 27 plus 32, 59. A1, A2, A3 are all in AP. What is this equal to? Wonderful. This is a classic question where we rationalize the denominator. 1 by square root of A1 plus square root of A2 into root of A2 minus root of A1 by root of A2 minus root of A1. Why am I writing it as A2 minus A1? Because I know A2 minus A1 is D, the common difference. Wonderful. So this is square root of A2 minus square root of A1 by A2 minus A1 plus square root of A3 minus square root of A2 by a3 minus a2 all the way till square root of an plus 1 minus square root of a1 by an plus 1 minus an. Brilliant. This denominator is equal to common difference. So we have 1 by common difference into a2 root a2 minus root a1 plus root a3 minus root a2 all the way till here. This gets cancelled with this. This will get cancelled with something all the way till here. So we'll have 1 by d into square root of an plus 1 minus square root of a1. But we don't have d. So what do we do? How do we simplify this? We need to find a common difference. Now an plus 1 is a1 plus n times d. We add common difference n times, will go from here to here. So an plus 1 minus a1 equals nd, or d equals an plus 1 minus a1 by n. We want 1 by d is n by an plus 1 minus a1, or our expression is square root of an plus 1 minus square root of a1 into n by an plus 1 minus a1. This by this, again an plus 1 minus a1 can be written as square root of an plus 1 plus square root of a1 into square root of an plus 1 minus square root of a1. So this part will get cancelled with this one, or we'll get n by square root of an plus 1 plus square root of a1. N by square root of an plus 1 plus square root of a1. Just this answer. Choice A. Consider the function f of x plus y equals f of x into f of y, where x and y are positive integers. F of 1 equals 2. F of a plus 1 plus f of a plus 2 plus f all the way to f of a plus n is 16 into 2 power n minus 1. F of a plus 1 equals f of a into f of 1. F of a plus 1 is f of a into 2. F of a plus 2 is f of a plus 1 into f of 1, which is f of a into 2 into 2. Oh, brilliant. We've got this. F of a plus 1 is f of a into 2. F of a plus 2 is f of a into 2 square. F of a plus 3 is f of a into 2 cube. F of a plus n is f of a into 2 power n. So what are we adding? We're adding f of a into 2 plus 2 square plus 2 cube all the way to 2 power n, or 2 times f of a into 1 plus 2 plus 2 square all the way to 2 power n minus 1. This is a GP. First term is 1, common ratio is 2, number of terms is n, product is a into r power n minus 1 by r minus 1. R minus 1 is 1. 2 times f of a into 2 power n minus 1. 2 power n minus 1. 2 times f of a into 2 power n minus 1. This is 16 times 2 power n minus 1, or f of a is 8. F of 1 is 2. F of 2 is f of 1 into f of 1, 4. F of 3 is f of 2 into f of 1, 8. Or f of 3 is 8. A is 3. Wonderful question. First you have to identify that this effectively becomes a geometric progression. Then simplify and find f of a. And know that f of 1 is 2, f of 2 is 4, f of 3 is 8. That is the sequence we are talking about. F of a is 8, or a should be 3. 5.55 to the power x equals 0.555 to the power of y equals 1000. It's an absolutely wonderful question. From exponents and logarithms, 1 by x minus 1 by y. What is this? Fine. I tried and struggled in this exam and didn't get it right. It took me a long time and I didn't get it and I got lost. I should have probably been better at handling this. And how do we do this? There's a 1 by x and a 1 by y. That should be a giveaway. Dealing with x, I want to deal with 1 by x. How do I simplify? 5.55 is 1000 to the power 1 by x. 0.555 is 1000 to the power 1 by y. The moment you rewrite it like this, you're through. How are we through? Divide one by the other. This is 10. So 5.55 by 0.555 is 10. This equals 1000 to the power 1 by x minus 1 by y. A power x minus a power y is a power x minus y. The same idea here. Brilliant. We are through. 1000 power 1 by x minus 1 by y is 10. What is 10? 10 is 1000 to the power 1 by 3. This is 1000 to the power 1 by x minus 1 by y, or 1 by x minus 1 by y is 1 by 3. Did all kinds of complicated logarithm stuff. The key to unlocking this, my question is asking for 1 by x and 1 by y. Don't somehow contrive to form 1 by x and 1 by y. You have to have a root to 1 by x instead of dealing with x. If you simplify this and say x, y minus x by x, y, and all that becomes complicated. Try to find x, try y, complicated. My answer is calling out for 1 by x. So I want to see 1 by x somewhere. I want to write an equation where the 1 by x is seen, and then you're through. Let x and y be positive real numbers. Positive real numbers. I really missed this one. In the exam, I missed out on this one funda. I don't think in this question, but something else. And then I got it wrong. Log x plus y to the base 5, x minus y to the base 5 is 3. X plus y into x minus y. So this is log of x square minus y square to the base 5 is 3. Or x square minus y square is 5 cube, which is 125. Log y to the base 2 minus log x to the base 2. That is log of y by x to the base 2 equals 1 minus log 3 to the base 2, which is log 2 to the base 2 minus log 3 to the base 2. Log y by x to the base 2 is log 2 by 3 to the base 2, or y by x is 2 by 3. Wonderful. We have x square minus y square is 125. Y by x is equal to 2 by 3. So x is 3 by 2 y. And so substitute that 3 by 2 y whole square minus y square is 125. So it's 9 by 4 y square minus 4 by 4 y square is 125. 5 by 4 y square is 125. 125 by 5 is 25. Y square is 100. Y is 10. Wonderful. Y is 10. Y cannot be minus 10. Therefore, we know that 5 by 4 into y square is 25. Y is 10. We know that x is 3 by 2 y, or x is 15. X into y is 15 into 10, which is 150. Key things here, using the product formula to simplify this, writing this 1 as log 2 to the base 2. With this, we'll get x square minus y square is something. The second one gives us x in terms of y, or y in terms of x. Simplify and find out. We are through. A regular question should be solved. I got this one wrong. I got this one so wrong that it was embarrassing. Fine, so I'm going to do this. I'm going to say mod x into 6x square plus 1 is 5x square. We have mod x and x. Remember, mod x whole square is same as x square. I'm going to say mod x equal to y. So call this as y. 6y square plus 1 equals 5y square. X square is mod x a whole square. So this way we can cancel a y. 6y square plus 1 is 5y. 6y square minus 5y plus 1 equal to 0. Number of solutions. Brilliant. We break this. 6y square minus 5y plus 1. 6y square minus 3y minus 2y plus 1. So it is 3y into 2y minus 1 into 2y minus 1 is 0. 3y minus 1 into 2y minus 1 equals 0. Y is 1 by 3 or 1 by 2. Brilliant. Now y is mod x. So x could be 1 by 3 or minus 1 by 3. 1 by 2 or minus 1 by 2. All of these will work. So there are 4 values for this. Brilliant. Theta is 4 and I did this and I got a minus 1. Why? Because at step 1 we have cancelled this y. We're cancelling y on both sides. So y equal to 0 will work. Y is 0, x is 0. X is 0 is a trivial solution. You can look at this and say, put x equal to 0, both sides go to 0. So there are not 4 solutions, 5 solutions. Every time you cancel on both sides, you've got to keep in mind that you simply cannot cancel 0 on both sides. That means you cancel, you're saying this cannot be 0. So you have to worry about the time where it becomes 0 and then account for that solution. So x is 1 by 3 minus 1 by 3, 1 by 2 minus 1 by 2 and 0. 5 possible values exist. a1 plus a2 plus a3 all the way till an is 3 times 2 power n plus 1 minus 2 for every n greater than or equal to 1. And a11 equals, let's find a1. Be 3 times 2 square minus 2. 3 times 4 minus 2, 2 which is 6. Let's do a1 plus a2. That's 3 times, putting n as 2, 2 cube minus 2, which is 3 times 8 minus 2, 6, which is 18, or a2 is 12. Let's do a1 plus a2 plus a3. This is 3 times 2 power 4 minus 2, 16 minus 2, 14, 3 times 14, which is 42. a3 is 42 minus 18 minus 6, 42 minus 18 minus 6, 42 minus 24. Sorry, this is a1 plus a2. 42 minus 18. 6, a1 and a2 are 6 and 12. a1 is 6, a2 is 12. Add these two, we get 18. a3 is 42 minus 18, 24. You can clearly see the pattern. a4 will be 48. a5 will be 96. This is 3 into 2 power 5. 3 into 2 power 4, 3 into 2 cube. a11 is 3 into 2 power 11. a1 is 3 into 2 power 1. a2 is 3 into 2 square. a11 is 3 into 2 power 11. 2 power 10 is 1024. 2 power 11 is 2048. 48 into 3 is 144. 6144. The other more mathematical way of doing it, a1 plus a2 all the way till an is 3 into 2 power n plus 1 minus 2. a1 plus a2 all the way till an minus 1 is 3 into 2 power n minus 2. Subtract one from the other, all of these disappear. We have only an, which is 3 into 2 power n plus 1 minus 6 minus 3 into 2 power n plus 6. This is 3 into 2 power n plus 1 minus 3 into 2 power n, but 3 into 2 power n into 2 minus 1, which is 3 into 2 power n, which is exactly what we got by filling in a few numbers. Population of town. It's a delightful question, very tough one. I kind of went from answer choices and fudged and got to the answer in the exam. So I'm not going to do that. I'm going to try to solve this algebraically. And so assume that we don't have these wonderful choices. The choices are present. This question becomes very simple. And I'm going to assume this is not present. Then type in and try solving this. The population of a town is P in the beginning of any year. Then it becomes 3 plus 2P in the beginning of the next year. The population at the beginning of 2019 is 1000. And the population at the beginning of 2034 will be 2019 is P. 2020 will be 2P plus 3. 2021 would be 2 into 2P plus 3 plus 3. 2022 would be 2 into 2P plus 3 times 2 plus 3 plus 3, and then so on. I'm going to expand this. This is 2P plus 3. This is 4P plus 9. This is 4p plus 9 into 2, which is 8p plus 18 plus 3, 21. So next term would be 16p plus 45. Term after that would be 32p plus 93 and so on. This into 2 plus 3. Fine, so it's a nice interesting question. The first pattern we notice is this goes as 2p, 4p, 8p, 16p, 32p. That part is simple. Fine, very nice, very simple. Fine, so this is going to be 2 power 1 into p, 2 square into p, 2 cube into p, 2 power 4 into p, 2 power 5 into p, so on. From 2090 to 2034, there are 15 years, 15 jumps. So finally, we've got to have a 2 power 15 into p. In our case, p is 1000. We'll worry about that. Plug that in the end. And that part we have solved. Next part, this is 3. It becomes 9. Why 9? 3 into 2 plus 3. Right? Now, what does it become? The next step, it becomes 3 into 2 into 2 plus 3 into 2 plus 3. Think about this. This 21, how does it come about? That is 3 plus 3 into 2 plus 3 into 2 square. This one would be 3 plus 3 into 2 plus 3 into 2 square plus 3 into 2 cube. Or if I extract a 3 outside, 1 plus 2 plus 2 square. This one, if you this 9, 3 outside, 1 plus 2. We're getting somewhere here. There's a geometric progression sitting here, a beautiful geometric progression. In year 1, we just have 3 into 1. In year 2, we have 3 into 1 plus 2. In year 3, we have 3 into 1 plus 2 square. Next, we'll have 3 into 1 plus 2 square plus 2 cube. Or, we keep on doing this. This is year 1, year 2, year 3, and so on. Finally, what will you get? Think about this. In year 3, there are 3 terms, 1 plus 2 square. In year 15, there will be 15 terms, 3 into 1 plus 2 square, all the way till 2 power 14. This we know it is 3 into 2 power 15 minus 1 by 2 minus 1, which is nothing. Or the total population would be 2 power 15 into p plus 3 into 2 power 15 minus 1. Or 2 power 15 into p plus 3 minus 3. P is 1000. So 2 power 15 into 1003 minus 3. This one. Going from answer choices is far simpler. We see there's a progression sitting in. We know there is 15 years. We know this 2 power 15 has to sit somewhere. This is out. This is out. This is the answer. Going from answer choices, this is very simple. But look, in the exam context, you can do answer choices. But for learning, it's better to see the textbook method. Because next time the idea will come up. The product of the distinct roots of x square minus 6 equals x plus 2. X square minus x minus 6. So this could be x square minus x minus 6 equals x plus 2. Or minus of x square minus x minus 6 equals x plus 2. Two possible solutions. In this case, x square minus x minus 6 should be greater than 0. In this case, x square minus x minus 6 should be less than 0. First, let's solve. Then we'll worry about the roots part later on. Becomes x square minus 2x minus 8 equal to 0. This is x minus 4 into x plus 2 equal to 0. X is 4 or minus 2. Fine. When x is 4, x square minus x minus 2 is 16 minus 4 minus 6. X square minus x minus 6. 16 minus 4 minus 6, which is 6. X equal to 4 works. X equal to minus 2. Minus 2 whole square minus of minus 2 minus 6. So 4 plus 2 minus 6 is 0. This side is 0. X equal to minus 2 also works. This side minus x square plus x plus 6 equals x plus 2. It gets knocked off. Minus of x square is 2 minus 6 equals minus 4. X square is 4. X is plus or minus 2. Minus 2 works. We need to think whether plus 2 would work. Best way to plug it in is to plug it in the equation. 2 square minus 2 minus 6. Modulus of 4 minus 2 minus 6. Modulus of 4 minus 8. Modulus of minus 4, which is 4. This side is 2 plus 2, which is 4. So x equal to 2 also works. X equal to 4 work. X equal to minus 2 work. X equal to 2 works. So product of the distinct roots, 4 into minus 2 into 2, minus 2 into 2, minus 16. Once again, I made the mistake in this one. I completely forgot that this solution was possible, messed it up and got a wrong answer. So don't rush through, solve it methodically. What I did is factorize this. I made it as modulus of x minus 3 into x plus 2 equal to x plus 2. And then cancel this and said modulus of x minus 3 should be 0. And then went nowhere with it. Fine, so x square minus x minus 6. Solve it methodically. Don't be in a hurry to cancel stuff off. So modulus of x minus 3 should be 1. Then got 2 roots and I completely forgot what I was cancelling, got into trouble. Fine, so don't cancel a number and a modulus. Don't worry. Don't ignore that when you're cancelling something, that root disappears. X plus 2, if you're cancelling on both sides, that means you're not worrying sufficiently about x plus 2 being 0. And that is a possibility here. And that's what I forgot. I forgot that if you're cancelling x plus 2 on both sides, you have to account for the fact that x plus 2 can be 0. That could work. So x equal to minus 2 is a very important solution, which I glossed over. Don't. Real roots. The number of real roots of the equation 2 cos x times x plus 1 is 2 power x plus 2 power minus x. Wonderful, wonderful, wonderful. To start with, I'm going to not think of this as an equation. Think of it as a left-hand side and a right-hand side separately. Should know this. 2 power x plus 2 power minus x is like y plus 1 by y. 2 power x is y, 2 power minus x will be 1 by y. Now, any expression the form y plus 1 by y is either greater than or equal to 2 or y plus 1 by y is less than or equal to minus 2. Think about it. 3 plus 1 by 3, 5 plus 1 by 5, root 2 plus 1 by root 2. Y plus 1 by y will be 2 when y is 1. Y plus 1 by y will be minus 2 when y is minus 1. Here 2 power x cannot be negative. So this part we don't have to worry about. So we can say 2 power x plus 2 power minus x is greater than or equal to 2. Wonderful. Now 2 cos anything is less than or equal to 2. Cos of something is less than or equal to 1. 2 cos anything is less than or equal to 2. Wonderful. So we've got this completely nailed down. This part has to be less than or equal to 2. This part has to be greater than or equal to 2. When is it possible? When this is equal to 2, this is equal to 2. So 2 power x plus 2 power minus x. When will it be equal to 2? When x is 1 or minus 1. When x is 1, this will be 2. Sorry. When 2 power x is 1, not x is 1. When 2 power x is 1 or when x is 0. 1 plus 1 is 2, not x is 1. When x is 1, it becomes 2 plus 1 by 2. When x is minus 1, it becomes 1 by 2 plus 2. That doesn't work. X has to be 0. 2 power 0 plus 2 power 0 is 2. And so x equal to 0 works. Now let's go to the cos part. 2 cos 0 into 0 plus 1 is 2 cos 0, which is 2 times 1, which is 2. Now this will be 1 even when x is minus 1. But when x is minus 1, this part won't be equal to 2. 2 cos minus 1 into minus 1 plus 1 is also 2. That is fine. But 2 power minus 1 plus 2 power minus of minus 1 is 5 by 2, not 2. So only one value works. The value that x is equal to 0. M and n are integers. Again, very delicious question. But if you know exponents, you are walking through this. Straight away, I'm going to look at this question and say, okay, I'm going to compare powers of 2, powers of 3. That's it, 2 and 3. And then put them together. So square root of 2 power 19 is 2 power 1 by 2 whole power 19 into 3 power 4 into 4 square is 2 power 4. 9 power m is 3 power 2m. 3 square power m into 8 power n is 2 power 3n equals 3 power n 2 power 4 whole power m into 2 power 6 whole power 1 by 4. 2 power 19 by 2 into 2 power 4 into 2 power 3n into 3 power 2m plus 4 equals 3 power n into 2 power 4m into 2 power 6 by 4, which is 3 by 2. 3 by 2, 19 by 2, divide this by this. 19 by 2 minus 3 by 2, 16 by 2, which is 8. So 2 power 8 into 2 power 4 into 2 power 3n into 3 power 2m plus 4 is 3 power n. This is 2 power 12. So 2 power into 4 power into 2 power 4m, just to complete it. 2 power 3n plus 12 into 3 power 2m plus 4 is 3 power n into 2 power 4m. 2m plus 4 is n. 3n plus 12 is 4m. Let me write this again. 2m plus 4 is n. 3n plus 12 is 4m. We want to find m, substitute n in terms of m. 3 times 2m plus 4 plus 12 is 4m. 6m plus 24 equals 4m. 24 equals 4m minus 6m, which is minus 2m, or m is minus 12. Just methodically combine powers of 2 powers of 3, put them together, and then simplify. It's a routine question. You should be nailing this in the exam. For any positive integer n, f of n is n into n plus 1 if n is even. So f of 2 is 2 into 3, 6. And f of n is n plus 3 if n is odd. F of 1 is 4. 8 times f of m plus 1 minus f of m equal to 2. Now, if this will vary, the equation will vary based on whether m were an odd integer or an even integer. So I'm going to break it into 2. M is even, m is odd. If m were even, f of m would be m into m plus 1. F of m plus 1 would be m plus 4. 8 times m plus 4 minus m into m plus 1 equal to 2. If m were odd, then m plus 1 is even. 8 times m plus 1 into m plus 2 minus of m plus 3. If m is odd, f of m is m plus 3. 8 times f of m plus 1. F of m plus 1 will be m plus 1 into m plus 2. 8 times this minus of m plus 3. This is equal to 2. Now, a little bit of a gut feel. The product of two numbers. M is odd. The product of two numbers will be 1 into 3. M is odd. That means the smallest value it can take is 2 into 3. 8 into 2 into 3 minus 1 plus 3, 4. This is way more than 2. This is a product of two conjugated numbers that will keep on going bigger and bigger vis-a-vis this. So gut feel tells me this is not going to work out. This will probably work out. 8m plus 32 minus m square minus m equals 2. 8m minus m is 7m. 32 minus 2 is 30 minus m square is 0. Or m square minus 7m minus 30 is 0. M minus 10 into m plus 3 is 0. M is 10 or minus 3, 10 works. Further, 10 works for the assumption that m is even. Otherwise, you would have had to worry about that. When m is even is when this is coming true. So m is even and m is 10. That works. So m equal to 10 works. So 10 is the even number for which this will be satisfied. M equals 10. We don't have to simplify for the other number. If 2n plus 1 plus 2n plus 3 plus 2n plus 5 all the way till 2n plus 47 is 5280. And so isolate this, we're done. 2n plus 2n plus 2n. We're going from 1 to 47 but counting only odd numbers. There are 24 terms. Plus 1 plus 3 plus 5 plus 7 all the way till 47. 24 terms. This is 2 minus 1, 4 minus 1, 6 minus 1, 8 minus 1, 48 minus 1. Each term is an even number minus 1. This is 24 into 2 minus 1. 24 terms equals 5280. Odd numbers, the first 24 odd numbers will add up to 24 square. 1 plus 3 plus 5 is 3 square. 1 plus 3 plus 5 plus 7 is 4 square. 1 plus 3 is 2 square. And so our 2n into 24 equals 5280 minus 24 square. This will be a multiple of 24. Let's cancel out 124. 2n equals 5280 by 24 goes 2 times 48 is 2 times 228 minus 24, or n equals 110 minus 12. 110 minus 12 is 98. 1 plus 2 plus 3 plus 4 till n is n into n plus 1 by 2. 98 into 99 by 2. 99 into 49, whatever that turns out to be. 9 9s are 81, 1 8, 9 4s are 36 plus 8. 441, 441, 1 5, 4851. When you're just breaking this, keeping the 2 n terms separate, keeping the 1 3 5 terms, the sum of first n natural numbers is n square. It's totally worthwhile remembering that. So we subtract that 24 square from this, equated to 2n into 24. And then let a be a real number. The roots of the equation x square minus 4x minus log a to the base 2 equal to 0 are real and distinct. Real and distinct if discriminant is greater than 0. Discriminant is b square minus 4ac. So minus 4 the whole square minus 4 into 1 into minus log a to the base 2 is greater than 0. 16 plus 4 times log a to the base 2 is greater than 0, or 4 plus log a to the base 2 is greater than 0. Log a to the base 2 is greater than minus 4. If log a to the base 2 were equal to minus 4, a would be equal to 1 by 2 power 4, which is 1 by 16. Log a to the base 2 is greater than this, or log a to the a should be greater than 1 by 16. a1, a2 be integers such that a1 minus a2 plus a3 minus a4 all the way till an is n for n greater than or equal to 1. These kind of questions become wonderful. You say a1 is 1, a1 minus a2 is 2, a1 minus a2 plus a3 is 3. a1 is 1, 1 minus a2 is 2, or a2 is minus 1. 1 minus a2 is 2. a2 is 1 minus 2, which is minus 1. Till here adds up to 2. Once you put this, it is 3. This is 2. You add this, you get 3. That means a3 is 1. Till this is 3. 3 minus a4 is 4, or a4 is minus 1. Very simple pattern. This is just 1 minus 1, 1 minus 1, 1 minus 1. Odd number terms are plus 1. Even number terms are minus 1. And now let's come to the question. A51, 52, 53 all the way till A1023. A51 is 1, minus 1, 1, minus 1, 1, minus 1. Finally ending with a plus 1, because A1023 is an odd number term. We need to add all of this. In pairs they'll get knocked off. the final plus 1 will remain, or the total is plus 1. A51 to A1023, there are an odd number of terms. So there is one more odd term than even term. Each odd term will cancel with each even term. The extra odd term is going to be 1. So the total is 1. F of mn equals f of m into f of n for every positive integer m and n. If f of 1, f of 2 and f of 3 are positive integers, f of 1 is less than f of 2 and f of 24 equals 54. Wonderful. F of 1 is less than f of 2. F of 2 equals f of 2 into f of 1. Either f of this tells us that f of 2 minus f of 2 times f of 1 is 0, or f of 2 into 1 minus f of 1 is 0. Either f of 1 is 1 or f of 2 is 0. If f of 2 were 0, then everything would become 0. Then f of 1 and f of 2 would be equal. That's not possible. So f of 1 is 1. They're positive integers. So f of 2 is greater than 1. That much we know. And it's a positive integer greater than 1. Right? F of 24 is 54. This is f of 3 into f of 8, or f of 3 into f of 2 into f of 4, or this is f of 3 into f of 2 whole cube. This is 54. F of 2 is a positive integer greater than 1, or f of 2 is 2. F of 2 is 3. 54 is 2 into 3 cube. Quite simply, from this we know that f of 2 is 3, f of 3 is 2, f of 1 is 1. F of 18 equals f of 2 into f of 3 whole square. 2 into 3 into 3, which is 3 into 2 square, which is 12. 5 power x minus 3 power y is 13438. 5 power x minus 1 plus 3 power y plus 1 is 9686. And there's 5 power x, there's 5 power x minus 1. So I'm going to say let 5 power x minus 1 equals k. There's 3 power y plus 1. Let 3 power y equals m. This is 5k minus m equals 13438. This k plus 3m equals 9686. Brilliant. Multiply this by 3. We get 15k plus minus 3m equals 1348438 into 3. 3 8s are 24, 4 2, 9 plus 2 11, 1 1, 12 plus 1 13, 3 1, 9 plus 1 10, 0 1, 3 plus 1 4. Fine. Now we add these two, we'll get 16k equals 6 plus 4 10, 0 1, 9 plus 1 10, 0 1, 7 plus 3 10, 0 1, 9 plus 1 10, 0 1, 50,000. 16k is 50,000. 50000. We can divide this by 16 wonderfully. 10,000 by 16. This is 10 power 4 by 2 power 4 is 5 power 4, 625. Or k is 625 into 5. This is 3 power 5. 5 power, sorry, this is 5 power 5. 5 power x minus 1 equals k, or x is 6. Brilliant, we have found x. Now we still need to find y. So that let's take this equation. K plus 3m is 9686. X is 6. 5 power x minus 1 is k. So 5 power 5. 5 power 5 plus 3m is 9686. 3m equals 9686 minus 3125. 6 minus 5 is 1. 8 minus 2 is 6. 6 minus 1 is 5. 9 minus 6561 is 3m, or m equals, dividing this by 3, 2 1 26 is 8, 2187. 3 power 1 is 3, 3 square is 9, 3 cube is 27, 3 power 4 is 81. 3 power 5 is 243. 3 power 6 is 729. 3 power 7 is 2187. M is 3 power y. 3 power y is 2187, or y is 7. We got x to be 6. X is 6, y is 7. X plus y is 13. I struggled long and hard for this question. For a long time I struggled with this question. It's a beautiful question. A square plus b square is 25. X square plus y square is 169. Ax plus by is 65. What is ay minus bx? Right? Looking at the choices, greater than 5 by 13, there's a subtraction thing here. Right? So generally a and b are symmetric, x and y are symmetric. That means if you swap x and y values, a and b values, everything should hold good. And that's what this is telling us. Correspondingly hold good. What that means, you cannot say it is greater than 5 by 13 because there's a subtraction involved here. And so this looks dicey to me. This looks very possible. These two also look reasonable. But we need to find some smart way of figuring this out. How do we do that? There's going to be some form of comparing a square plus b square with 2ab involved. A square plus b square minus 2ab, a square plus b square plus 2ab, something like that. Right, so now think about this. This is 5 square. This is 13 square. This is 5 into 13, the whole square. If I square this and multiply these two, I should be the same. A square plus b square into x square plus y square is equal to ax plus by whole square. Not algebraically. This is 25. This is 169. This is 65 square. Numerically, in this particular question, I'm not saying algebraically they are same. In this particular question, if you multiply these two, you should get this square. Right? There's something special about that 65. That is 5 into 13. So if we expand this, we get a square x square plus a square y square plus b square x square plus b square y square equal to a square y square plus a square x square plus b square y square plus 2ax by. This gets knocked off with this. This gets knocked off with this. A square y square plus b square x square equals 2ax by. It's a wonderful expression, especially if you write it like this. A square y square plus b square x square minus 2abxy or ax by is equal to 0. Make sense of this and then we are through. Can you make sense of this? Can you think about this and make sense of this? This is nothing but ay minus bx the whole square. Ay minus bx the whole square is equal to 0, or ay minus bx is equal to 0. K is equal to 0. Delightful question. It was very, very, very tough question. You need like lots of comfort with algebra. But the key thing here, you're given a 5 square and a 13 square and a 5 into 13 here. Therefore, we might be able to do something with that. Right? So keep that in mind. Be switched on about it, but otherwise a very tough question. I took a long time to crack this. Totally not worth doing in the exam. The way I mulled around and fooled around and got lost in algebra, all that I did a square plus b square greater than or equal to 2ab, x square plus y square greater than or equal to 2xy. I squared this, I multiplied this and this for some reason. Didn't go anywhere with all that. Then came around to this method. The real roots of the equation, 2 power 6x plus 2 power 3x plus 2 minus 21 equal to 0. All of these questions, idea is to convert this into a quadratic. Fine. So 2 power 3x the whole square is 2 power 6x. So if we call this as y, this is y square. What is 3 power 3x plus 2? That's nothing but 2 power 3x into 2 square. Or this equation becomes y square plus 4y minus 21 equal to 0. Once you crack this, we're pretty much through. 2 power 3x plus 2 is 2 power 3x into 2 square. 2 square is 4. So this is y square plus 4y minus 21 equal to 0. This is nothing but y plus 7 into y minus 3 equal to 0. This 4 we are splitting as 7 and minus 3. Y equal to minus 7 or plus 3. 2 power 3x cannot be negative. Why is 2 power 3x? Remember, or this is quite simply 2 power 3x equal to 3. Some log is involved. Right away we take log to the base 2 of 2 power 3x is log 3 to the base 2. This is 3x equals log 3 to the base 2, or x is 1/3 of log 3 to the base 2. Log 3 to the base 2 by 3. That is the right answer. First step, convert this to a quadratic equation. Get two roots. One of the roots does not work out. Take the other root. Bring back x into the system. 2 power 3x is equal to 3. Then take log on both sides. You're through. Number pairs. How many pairs m comma n of positive integers satisfy the equation m square plus 105 is n square? To start with integers and positive integers. We're talking about natural numbers. First step, we write this as 105 equals n square minus m square. We know these are positive integers, so n is greater than m. This can be broken as n plus m into n minus m. So product of two natural numbers is 105. 105 can be written as 3 into 35. 3 into 5 into 7. And so that's 8 factors. It can be broken up in 4 different ways. So it can be written as 1 into 105, 3 into 35, 5 into 21, 7 into 15. Each of those will give us one pair of integers. Remember, n plus m has to be greater than n minus m. N and m are natural numbers. N is greater than m. This has to be greater than this. So we need to worry about only 105 into 1. We don't have to worry about 1 into 105. Likewise, 35 into 3, 21 into 5, 15 into 7. 4 different combinations. Each of them will yield a pair of positive integers. So 4 pairs. The quadratic equation x square plus bx plus c equal to 0 has two roots, 4a and 3a, where a is an integer. Which of the following is a possible value of b square plus c? Brilliant. Sum of the roots, that is 4a plus 3a equals minus b. Product of the roots is 4a into 3a. This is c. Sum of the roots is minus b by a. Product of the roots is c by a. So 7a is minus b. 12a square is c. b square plus c. b square is 49a square. c is 12a square. If we add these two, b square plus c is 49a square plus 12a square, which is 61a square. So our answer, fine, should be a multiple of 61 and should be a perfect square. Perfect square into 61 should be one of these. And so 61 into a square cannot be 361. 361 is not a multiple of 61. 549, 427 and 549. 427 by 61. 61 into 7 is 427. It's a multiple, all right, but into 7. 7 is not a perfect square. This doesn't work. 549 is 61 into 9. 540 plus 9. This works. 9 is a perfect square. A could be 3. This is a possible value. 3721 by 61. I'm just verifying this. In an exam, I'm probably not doing this. This goes 6 times. 366 and 61. 61 times 61. 61 is not a perfect square. This won't work. Only this works. Brilliant. Done. Because a is an integer. If x is a real number, then square root of log of 4x minus x square by 3 to the base e is a real number if and only if. Square root of a number. So straight away we know log of 4x minus x square by 3 to the base e should be greater than or equal to 0. Brilliant. Only then we can find square root. Or now let's go to the next step. Log of something is greater than or equal to 0, or that something 4x minus x square by 3 should be greater than or equal to 1. Log 1 to the base e is 0. Anything more than 1, the log of that number will be greater than 0. So 4x minus x square should be 4x minus x square by 3 should be greater than or equal to 1, or 4x minus x square minus 3 should be greater than or equal to 0. This minus 3 comes over this side, or x square minus 4x plus 3 is less than or equal to 0. X minus 1 into x minus 3 is less than or equal to 0, or x should lie between 1 and 3, including 1, including 3. 1 less than or equal to x, less than or equal to 3. That is the answer we are looking for. What is the largest positive integer such that n square plus 7n plus 12 by n square minus n minus 12 is also a positive integer? It's a delightful question. Anytime you have a quadratic by a quadratic, don't deal with two quadratics, deal with one. How so? Call this as n square minus n minus 12 plus some adjustment term divided by n square minus n minus 12. Brilliant. Now this works. What is the adjustment term? 8n, because minus n plus 8n is 7n plus 24. So this becomes 1 plus 8n plus 24 by n square minus n minus 12. Now let's look at this. If the whole thing has to be an integer, this has to be an integer. 8n plus 24 is 8 times n plus 3. N square minus n minus 12 is n minus 4 into n plus 3. N cannot be minus 3, so this can be knocked off. 8 by n minus 4 has to be an integer. So the best case scenario, this is equal to 1. That's when n will be as high as possible. If you put 8 equals n minus 4, n is 12. N were any more than 12, 13, 14, 15, 16, this will become a proper fraction, a positive proper fraction, and it will not be an integer, or the largest value n can take is 12. Another way of doing this, factorize this, n plus 3 into n plus 4 by n plus 3 into n minus 4. N plus 4 by n minus 4 should be an integer. What is the maximum value n can take? 12 plus 4 by 12 minus 4 works. 16 by 8 is 2. Then you can simplify. The smaller this integer is, the larger value n can take. Put it as 2, simplify, you're through. Let us be the set of all points xy in the xy plane such that mod x plus mod y less than or equal to 2. Wonderful. Mod x plus mod y less than or equal to 2. I know this shape, mod x plus mod y equal to 2. Put x equal to 0, y has to be plus 2 or minus 2. Put y equal to 0, x is plus 2 or minus 2. This region is a set of straight lines. Zero comma 2, 2 comma 0, 0 comma minus 2, minus 2 comma 0. And mod x is greater than or equal to 1. Mod x equal to 1 will happen when x is 1 or minus 1. And so mod x is greater than or equal to 1. That is, mod x equal to 1, x equal to 1 would be a line like this. X equal to minus 1 would be a line like this. Mod x greater than or equal to 1 would be either this region or this region. Mod x plus mod y less than or equal to is the square, which is tilted and makes look like a diamond. Then the area in square units represented by s. Represented by s is this. What are the points here? This point will be 1 comma 1. This will be 1 comma minus 1. Will be minus 1 comma 1, minus 1 comma minus 1. This region. If you find one area, we can find the other. This distance is 2. Height is 1. So we have a triangle with base 2 and height 1. Area would be half into 2 into 1. Just 1 square unit. Here there is 1 square unit. Here there is 1 square unit. The area in square units represented by S is 2 square units. Wonderful question. You need to be comfortable with drawing the diagram for this, imagining this, and then drawing the diagram, finding the shaded region, and then simplifying that.